Imagine a place in the universe where stars are packed so tightly together that if you were standing on one of them, the sky wouldn't be dark. Instead, you'd see an endless ocean of stars, so close that the night would be brighter than day. A place where gravity is so intense that entire star systems orbit a massive black hole at insane speeds, trapped in a cosmic dance that could go on for billions of years. These places are real, and they're called hypercompact stellar systems. But what exactly are they? Why do they exist? And how did they form? Most people have never even heard of hypercompact stellar systems. They're not like the usual galaxies or star clusters we're used to. There's something completely different, something that defies expectations. And the story behind them takes us deep into the heart of the universe's most extreme environments. These systems shouldn't even exist, yet they do. And understanding them could unlock some of the biggest mysteries in astrophysics. The first time scientists stumbled upon one of these strange stellar formations, they were baffled. They expected to find normal star clusters, but instead, they found a tightly bound group of stars orbiting a supermassive black hole at ridiculous speeds, so fast that it was clear something extremely powerful was holding them together. But what's even more bizarre is how these systems came to be. The best explanation we have is that they are the remnants of entire galaxies that have been torn apart in violent cosmic collisions. Imagine a supermassive black hole at the center of a galaxy, pulling in thousands, maybe millions, of stars. Now picture that entire galaxy getting yanked away by the gravity of another galaxy, leaving only the black hole and the closest surrounding stars behind. That's a hypercompact stellar system. It's like a ghost of a galaxy, a tiny, high-speed fragment of what was once an entire collection of billions of stars. And that's just the beginning. These systems don't just exist, they thrive in some of the most dangerous regions of space. They move through the universe at breakneck speeds, faster than almost anything else we know of, because they were flung away by the gravitational forces of massive galactic collisions. Some of them are moving so fast that they could eventually escape the Milky Way entirely, becoming intergalactic wanderers, small, star-packed remnants of galaxies that no longer exist. But here's where things get really weird. The stars inside these systems aren't just moving fast, they're surviving in an environment that should, by all logic, rip them apart. When stars are packed so closely together, they should collide and merge far more often than they do in normal star clusters. Yet, hypercompact stellar systems seem to defy these expectations. Scientists believe that the immense gravity of the central black hole stabilizes these systems in a way we don't fully understand yet. It's as if the black hole itself acts as a cosmic anchor, preventing the system from unraveling. And then there's the question of what happens to these systems over time. If they keep moving at such high speeds, do they eventually slow down? Do they merge with other galaxies? Do they just drift through the universe forever? These are the kinds of questions that keep astrophysicists up at night. Hypercompact stellar systems also challenge our understanding of black holes themselves. Most of what we know about black holes comes from studying them in the centers of galaxies, where they're surrounded by enormous amounts of matter. But in these systems, we see a different side of them. Here, the black hole isn't just devouring everything around it, it's actually holding an entire system of stars together, acting like a gravitational shepherd guiding its cosmic flock. But there's more to this mystery. If these systems really are the leftover cores of galaxies that were ripped apart, then that means there could be far more of them out there than we currently know about. Some might be drifting through intergalactic space, nearly invisible because they're so compact and hard to detect. Others might be hiding within larger galaxies, blending in so well that we haven't even noticed them yet. And here's where things get even crazier. If these systems really are remnants of shredded galaxies, then studying them could tell us a lot about how galaxies evolve and interact over billions of years. We often think of galaxies as stable, unchanging structures, but in reality, they are constantly colliding, merging, and sometimes even being torn apart. Hypercompact stellar systems are like the cosmic fossils of these violent events, offering us a glimpse into a past we would never be able to see otherwise. What's even more mind-blowing is the possibility that some of these systems could contain planets. If they do, those planets would exist in one of the most extreme environments imaginable, trapped in a gravitational tug-of-war between their parent stars and a supermassive black hole. If life could somehow exist on a planet in one of these systems, it would experience a sky unlike anything we've ever seen. Instead of a distant sun, there would be a swarm of stars so close together that the entire sky would be flooded with light. And looming in the background would be the black hole itself, an invisible giant warping the very fabric of space around it. Even though hypercompact stellar systems were only recently discovered, they could hold some of the most important secrets about the universe's history. By studying them, we could learn about how galaxies are destroyed, how stars survive in extreme environments, and even how supermassive black holes influence the structures around them. But there's one big problem: these systems are incredibly hard to find. They're small, fast-moving, and often lost in the vastness of space. The only reason we even know they exist is because we've managed to spot a few that happen to be in just the right place at the right time. Who knows how many more are out there, waiting to be discovered? And that leads to an even bigger question. Could one of these systems be on a collision course with the Milky Way? If a hypercompact stellar system were headed in our direction, what would happen? Would it tear through our galaxy, disrupting everything in its path? Could it even reach our solar system? The idea sounds like something out of science fiction, but in the vastness of space, anything is possible. Hypercompact stellar systems are among the most bizarre and least understood objects in the universe, but their implications are profound. If they really are the remnants of galaxies torn apart by cosmic collisions, then each one tells a story of destruction, survival, and the immense power of gravity. They challenge our understanding of how galaxies interact, how stars behave under extreme gravitational forces, and how black holes shape the universe around them. But what's truly mind-boggling is how these systems move. When a galaxy collides with another, the supermassive black hole at its center doesn't just sit there. It gets flung out at incredible speeds due to the gravitational forces at play. This process, known as gravitational recoil, is what gives birth to hypercompact stellar systems. As the black hole is ejected, it carries with it the closest surrounding stars, forming a compact, high-speed stellar cluster. Some of these systems are moving so fast that they're on trajectories that could eventually take them completely out of their home galaxies, turning them into intergalactic wanderers. Imagine this: a hypercompact stellar system, moving through space at thousands of kilometers per second, completely detached from any galaxy, drifting endlessly through the void between galactic clusters. The sheer scale of this is almost impossible to comprehend. These systems are so small compared to entire galaxies that they're like tiny cosmic lifeboats, carrying their trapped stars on an eternal journey through the universe. But there's something even stranger. Hypercompact stellar systems could contain some of the oldest stars in the universe. If they were once part of massive galaxies that formed billions of years ago, then the stars inside them could be ancient, older than our own sun, possibly even formed in the early days of the universe. Studying these stars could give us a direct look into the past, helping us understand how the first galaxies evolved and what the universe was like in its infancy. And then there's the mystery of what happens when these systems eventually slow down or encounter other massive objects. If a hypercompact stellar system passes close to another galaxy, could it be captured by that galaxy's gravity? Could it merge with an existing star cluster? Or would it simply continue its endless journey, unaffected by anything around it? These are the kinds of questions that keep astrophysicists searching for more of these rare systems. But finding them is incredibly difficult. Since they're small and fast-moving, they don't give off the same kind of light signature as galaxies or regular star clusters. Most of the time, they're only detected when astronomers notice stars moving in ways that don't make sense, stars that appear to be orbiting something massive and invisible at incredible speeds. Only by carefully analyzing their motion can scientists determine that they're part of a hypercompact stellar system. One of the most fascinating aspects of these systems is their relationship with the black hole at their core. Normally, we think of black holes as destructive, devouring everything that comes too close. But in a hypercompact stellar system, the black hole plays a different role. Instead of tearing the stars apart, it holds them together. Its immense gravity keeps the stars bound in an incredibly tight orbit, creating a gravitational balance that allows the system to exist. But this balance is fragile. Over time, interactions between the stars and the black hole could lead to dramatic changes. Some stars might be ejected entirely, flung out at speeds so high that they become rogue stars, traveling alone through space. Others might spiral in closer to the black hole, eventually being consumed. In some cases, the system might become unstable, leading to a slow disintegration over millions or even billions of years. And what about the possibility of planets? If planets exist in these systems, they would experience some of the most extreme conditions imaginable. The intense gravitational forces could stretch and deform planets, creating strange, elongated worlds unlike anything in our solar system. The constant movement of stars could also make planetary orbits highly unstable, meaning that any planet in one of these systems would be at constant risk of being flung into deep space or dragged toward the central black hole. But if a planet could somehow survive in a hypercompact stellar system, the view from its surface would be unlike anything we've ever seen. Instead of a distant sun, the sky would be filled with dozens, maybe hundreds, of bright stars, all packed together so tightly that there would be no true night. The black hole at the center would warp space itself, creating strange visual distortions and gravitational lensing effects that would make the stars around it appear stretched and twisted. The more we learn about hypercompact stellar systems, the more questions arise. Could they be more common than we think? Are there some hiding in our own galaxy, unnoticed because of their small size? Could studying them help us understand how black holes interact with their surroundings in ways we've never considered before? And most intriguingly, could there be other types of hypercompact systems out there, ones that don't just contain stars, but also other exotic objects like neutron stars or even small black holes? If so, then hypercompact stellar systems might not just be rare, isolated phenomena. They could be part of a much larger cosmic puzzle, one that could change the way we think about the structure of the universe itself. The more we explore the universe, the more we realize that it is far stranger than we ever imagined. Hypercompact stellar systems are just one piece of this vast, mysterious cosmos, a glimpse into the violent, chaotic, and awe-inspiring forces that shape the galaxies around us. If hypercompact stellar systems are more common than we think, then they could be hiding in plain sight, masquerading as dense star clusters or faint, fast-moving objects in the vastness of space. This raises the question, how many of them are out there, and why haven't we found more? The simple answer is that they are incredibly difficult to detect. Unlike galaxies, which emit light across vast distances and contain billions of stars, hypercompact stellar systems are tiny in comparison, so small that they can easily be mistaken for other cosmic phenomena. The best way to find them is by tracking their motion. Since they are moving at extreme velocities, they stand out against the slower-moving background of the universe. But even this method has its challenges. Many of these systems may be traveling through the vast emptiness between galaxies, far away from any region we routinely observe. This means that some hypercompact stellar systems could remain completely undetected, drifting alone in the cosmic dark. But what happens when one of these systems crosses paths with another galaxy? Could it be captured by the gravitational pull of a massive galaxy, becoming part of a new environment after being ejected from its original home? Theoretically, yes. If a hypercompact stellar system comes close enough to another galaxy, it could be slowed down by the galaxy's gravity and eventually pulled into orbit. This could lead to some fascinating scenarios, such as a rogue star cluster suddenly appearing in the outer reaches of a galaxy where no such cluster should exist. However, the opposite could also happen. If a hypercompact stellar system is traveling fast enough, it might pass straight through another galaxy without being captured, much like a bullet shot through a cloud of dust. In this case, it would continue on its journey, unaffected by the new galaxy's gravitational influence. The more we consider these possibilities, the more we realize just how dynamic and unpredictable the universe can be. Hypercompact stellar systems challenge our traditional understanding of galaxy formation and star evolution. They force us to rethink how black holes interact with their surroundings and what happens when entire galaxies are torn apart by gravitational forces. And then there's the question of time. If these systems were created billions of years ago, how many still exist today? Are some of them slowly decaying, losing stars over time until they eventually dissipate entirely? Or are they stable enough to persist for the lifetime of the universe, remaining as eternal wanderers in the void? One way to answer these questions is by studying the stars within these systems. If we can determine their ages and chemical compositions, we might be able to piece together their histories. For example, if the stars in a hypercompact stellar system all show signs of having formed at the same time, that would suggest they were once part of a single galaxy that was destroyed in a catastrophic event. On the other hand, if the stars are of mixed ages, that might mean the system has captured new stars over time, possibly by passing through regions of space with high stellar density. This brings us to another intriguing possibility. Could hypercompact stellar systems grow over time? If they pass through dense star-forming regions, could they accumulate new stars, becoming even more massive and complex than before? If so, then these systems might not just be relics of past galaxy collisions. They could be evolving structures, changing and adapting as they travel through the universe. And if hypercompact stellar systems can grow, could they eventually become something else entirely? Could they merge with other similar systems, forming larger and more complex structures? Could they, under the right conditions, become the seeds of new galaxies, starting the process of galactic formation all over again? The idea of a hypercompact stellar system evolving into something else is both fascinating and perplexing. We tend to think of galaxies, star clusters, and other cosmic structures as static objects that remain the same for billions of years. But in reality, everything in the universe is in motion, constantly changing. If hypercompact stellar systems are part of this grand cosmic evolution, then studying them could give us insights into the birth and death of galaxies themselves. One of the biggest challenges in studying these systems is their black holes. A hypercompact stellar system, by definition, has a central supermassive black hole, but these black holes are often difficult to observe directly. Unlike the black holes at the centers of large galaxies, which can be detected by the immense gravitational pull they exert on surrounding matter, the black holes in hypercompact stellar systems are much smaller and harder to distinguish from the stars orbiting them. However, there are ways to detect them. One method involves looking for signs of gravitational lensing, a phenomenon in which the intense gravity of a black hole bends the light from objects behind it. If we find a small, fast-moving cluster of stars that also exhibits gravitational lensing effects, that could be a strong indication that a hypercompact stellar system is present. Another method involves searching for X-ray emissions. When a black hole consumes matter, it often releases powerful X-ray radiation. If a hypercompact stellar system's black hole is actively feeding on gas or stars, it could produce detectable X-ray signals that would help us locate and identify it. But what if the black hole is dormant? Many black holes spend most of their time in an inactive state, not actively consuming matter. In these cases, detecting them becomes much harder. Scientists must rely on indirect clues, such as the high speeds of the surrounding stars, to infer the presence of a black hole. This raises yet another question: could hypercompact stellar systems contain multiple black holes? If a galaxy was torn apart in a particularly violent collision, could more than one black hole have survived, each one surrounded by its own small cluster of stars? If so, then some of these systems might not just have a single black hole at their core, but multiple black holes locked in a complex gravitational dance. If this turns out to be true, then hypercompact stellar systems could also be prime candidates for gravitational wave events. When black holes orbit each other closely, they release gravitational waves, ripples in the fabric of spacetime. If a hypercompact stellar system contains two or more black holes that are slowly spiraling toward each other, they could eventually merge, creating one of the most powerful gravitational wave signals in the universe. This means that studying these systems isn't just about understanding their past, it's also about predicting their future. If we can identify hypercompact stellar systems that contain merging black holes, we might be able to predict when and where the next big gravitational wave event will occur. And that leads us to one of the most mind-blowing implications of all. Could there be hypercompact stellar systems in our own galactic neighborhood? Could there be one hidden somewhere in the Milky Way, unnoticed because of its small size and high speed? If there is, then finding it could change everything. It would mean that these systems aren't just rare anomalies. They're an important, overlooked part of how galaxies evolve. It would also mean that our own galaxy has experienced more violent collisions and interactions than we ever suspected. And if we do find one close to home, what else might we discover? Could there be even stranger systems out there, formed by even more extreme cosmic events? Could we be on the verge of uncovering an entirely new class of astronomical objects that redefine our understanding of the universe? The search for hypercompact stellar systems is only just beginning. But as our telescopes and detection methods improve, we may soon uncover more of these elusive objects, each one telling a story of destruction, survival, and the incredible forces that shape the cosmos. If hypercompact stellar systems are more common than we think, then the next logical step is to figure out just how many might exist and where they could be hiding. The problem is that these systems are so small, so fast, and so faint that they blend in with the cosmic background, making them nearly invisible to conventional astronomical surveys. Unlike the bright, sprawling galaxies that dominate the night sky, hypercompact stellar systems don't announce their presence with grand spiral arms or glowing gas clouds. Instead, they are stealthy wanderers, difficult to distinguish from dense star clusters or even individual stars. To find more of them, scientists must rely on indirect evidence. One method is to track high-velocity objects that appear to be moving too fast for a typical star cluster. Most stars in the universe follow predictable orbits, dictated by the gravitational pull of their host galaxies. But hypercompact stellar systems are different. They don't follow these neat patterns. Instead, they zip through space at breakneck speeds, their movement dictated by the violent forces that ejected them from their original galaxies. Astronomers have already found stars moving at incredibly high speeds, so-called hypervelocity stars, which are thought to have been flung out of the Milky Way by interactions with our galaxy's central supermassive black hole. If individual stars can be ejected this way, then entire star clusters can too. This means that some hypervelocity objects we've detected might not be lone stars at all but instead could be full-fledged hypercompact stellar systems, disguised as single points of light in the vastness of space. Another promising way to detect these systems is through gravitational lensing. When a massive object passes in front of a more distant background light source, it bends the light in a way that can be measured. If we detect an unexpected gravitational lensing event caused by an object that appears too small to be a galaxy but too massive to be a single star, that could be a clue that we're looking at a hypercompact stellar system. But let's take this one step further. If hypercompact stellar systems exist in large numbers, then their presence could help solve another cosmic mystery, the question of missing mass. Astronomers have long struggled to account for all the mass in the universe. While dark matter is believed to make up a significant portion of this missing mass, there's also the possibility that small, hard-to-detect objects, like hypercompact stellar systems, are contributing to the overall mass budget of the universe in ways we haven't yet realized. If thousands or even millions of these systems are floating through intergalactic space, each containing a supermassive black hole, then they could collectively make up a significant amount of hidden mass. They wouldn't solve the dark matter problem entirely, but they could help bridge the gap between what we see and what we know must exist. This also raises an even bigger question. If hypercompact stellar systems are remnants of galaxies that have been torn apart, then how many galaxies have truly been destroyed over cosmic time? When we look at the night sky, we see countless galaxies scattered across space, but are we only seeing the survivors? How many galaxies have already been ripped apart, their remnants reduced to these tiny, fast-moving clusters of stars? If we could somehow rewind the universe, tracing the paths of all known hypercompact stellar systems back to their origins, what kind of picture would emerge? Would we find that the universe was once far more populated with galaxies than it is today, and that many of those galaxies have already been devoured, their remains now scattered across the cosmos as these enigmatic star systems? And if galactic destruction is this common, what does that mean for the future? Could our own Milky Way one day be torn apart in a similar way, leaving behind a hypercompact stellar system of its own? It's an unsettling thought, but one that's worth considering. The universe is a place of constant motion and evolution. Nothing stays the same forever, not even entire galaxies. The more we study hypercompact stellar systems, the more they challenge our understanding of how galaxies live and die. They force us to reconsider the true scale of destruction in the universe and to ask whether the galaxies we see today are just the lucky few that have managed to survive. But perhaps the most exciting thing about these systems is that we are only just beginning to understand them. Every new discovery brings more questions, and with advancements in telescope technology and data analysis, we may soon uncover even more of these hidden relics of the cosmos. Could they hold the key to understanding galaxy mergers? Could they reveal secrets about black hole interactions that we've never even considered? Could they be the missing link between normal galaxies and the supermassive black holes that exist in the void between them? One thing is certain: hypercompact stellar systems are more than just rare oddities. They are evidence of the universe's most violent and dramatic events, frozen in time, waiting for us to uncover their secrets. And the deeper we look, the more we might realize that these mysterious, fast-moving clusters of stars are telling us something fundamental about the fate of galaxies, the evolution of black holes, and the hidden forces that shape the universe itself. If hypercompact stellar systems truly are the remnants of galactic destruction, then studying them isn't just about understanding rare astronomical objects. It's about uncovering the history of violence in the universe. Every hypercompact stellar system we find is a clue, a surviving fragment of a cosmic battle that played out millions or even billions of years ago. And the more we find, the more we begin to piece together a hidden narrative, one where galaxies are not as stable or permanent as they seem. We tend to think of galaxies as vast, unchanging structures, existing in peaceful isolation, slowly evolving over billions of years. But the reality is far more chaotic. Galaxies are constantly interacting, colliding, merging, and even being torn apart by the gravitational forces of larger neighbors. The universe is a battlefield where the strong consume the weak, where smaller galaxies are stripped of their stars, and where even the most massive structures are subject to the relentless pull of gravity. Hypercompact stellar systems are the leftover evidence of these encounters. When a smaller galaxy is pulled into the gravitational grasp of a larger one, its outer layers are stripped away first. Stars at the edges of the galaxy are scattered, some flung into intergalactic space, while others merge with the dominant galaxy. But the very core of the galaxy, the region where stars orbit most tightly around the central supermassive black hole, is harder to disrupt. Instead of being completely absorbed, the core is sometimes ejected at high velocity, sent hurtling into space as an independent structure, a hypercompact stellar system. But here's where it gets even more fascinating. If these systems are indeed the cores of destroyed galaxies, then each one should contain clues about the galaxy it came from. The stars in a hypercompact stellar system are not random. They once belonged to a larger structure, and their chemical compositions, ages, and orbital patterns hold a fossil record of that galaxy's past. By studying the stars in these systems, we might be able to reconstruct the galaxies they were once part of. This means that every hypercompact stellar system is essentially a time capsule. It carries within it the history of a lost galaxy, a snapshot of what once was. And given how difficult it is to study galaxies that have been fully absorbed or destroyed, these systems might be our only window into the fates of countless galaxies that no longer exist. But there's another side to this mystery. If hypercompact stellar systems are the cores of dead galaxies, then what happens to their supermassive black holes? Every large galaxy is thought to contain a supermassive black hole at its center, millions or even billions of times the mass of the Sun. If the galaxy is torn apart, does the black hole remain in the core, traveling with the hypercompact stellar system? Or could it be ejected entirely, sent drifting through intergalactic space as a rogue black hole? This is one of the most intriguing implications of hypercompact stellar systems. If they are indeed traveling at extreme speeds through space, then the supermassive black holes they contain must be moving as well. And that raises a stunning possibility. There could be rogue supermassive black holes, each millions of times the mass of the Sun, drifting alone in the darkness, completely separated from any galaxy. These rogue black holes would be incredibly difficult to detect. Unlike black holes at the centers of active galaxies, which feed on surrounding gas and produce enormous amounts of radiation, a rogue black hole might have little or no material to consume. It would be essentially invisible, detectable only through its gravitational influence on nearby stars or through the way it bends light from distant objects. Some astronomers believe that we've already found hints of such objects. There have been cases where stars appear to be orbiting something massive, yet no visible source of light is present. These could be rogue supermassive black holes, remnants of galaxies that were destroyed long ago. If true, then hypercompact stellar systems are not just fascinating on their own. They could be the key to proving that black holes can be ejected from galaxies entirely. But what happens if a rogue black hole, moving at immense speed, collides with another galaxy? Could it trigger new rounds of galactic mergers? Could it disrupt the delicate balance of stars within a galaxy, sending them flying in all directions? Could it even create new hypercompact stellar systems by interacting with the cores of other galaxies? These are the kinds of questions that make hypercompact stellar systems one of the most exciting and mysterious topics in astrophysics. They challenge everything we thought we knew about galaxies, black holes, and the way the universe evolves over time. And the more we study them, the more they seem to reveal about the hidden forces shaping the cosmos. But perhaps the biggest mystery of all is just how many of them are out there. If hypercompact stellar systems are rare, then they might be nothing more than fascinating anomalies, curious remnants of an unusual galactic process. But if they are common, then they could rewrite our understanding of the universe. How many galaxies have already been destroyed? How many hypercompact stellar systems are speeding through intergalactic space right now, invisible to our telescopes? Could some of these systems be closer than we think, perhaps even within the local group, the small cluster of galaxies that includes the Milky Way and Andromeda? The only way to answer these questions is to keep looking. New telescopes, like the James Webb Space Telescope and upcoming space observatories, might finally have the sensitivity needed to detect more of these elusive objects. And when we do, we may find that the universe is far more chaotic, far more violent, and far more filled with the remnants of destruction than we ever imagined. Hypercompact stellar systems are not just another astronomical curiosity. They are the smoking guns of galactic warfare, the last echoes of galaxies that have been torn apart. They are cosmic refugees, drifting alone in the void, carrying the last remnants of long-dead worlds. And as we continue to uncover their secrets, they may force us to rethink everything we thought we knew about the fate of galaxies, the movement of black holes, and the hidden structure of the universe itself. Hypercompact stellar systems, HCS, are like footprints left behind after a great cosmic struggle, small but powerful remnants that hint at the violent history of galaxies. As astronomers continue to search for these elusive objects, new questions emerge. How many of these systems have we missed? Could some be hiding within our own galactic neighborhood? And most importantly, what do they tell us about the fate of galaxies, black holes, and the universe itself? One of the biggest challenges in studying hypercompact stellar systems is their sheer speed. These objects are often moving at thousands of kilometers per second, far faster than most stars and galaxies. This incredible velocity makes them difficult to detect because traditional surveys often assume that objects remain relatively fixed in position over time. A hypercompact stellar system, however, could move significantly between observations, making it easy to overlook. But what if some of these systems are closer than we think? Astronomers have speculated that some hypercompact stellar systems may exist within the local group, the small collection of galaxies that includes the Milky Way, Andromeda, and several smaller satellite galaxies. If true, then we may be able to study them up close, revealing details about their structure, composition, and motion that would be impossible to see in more distant systems. The search for these objects is complicated by another factor, their unusual brightness. Hypercompact stellar systems are incredibly dense, meaning they pack an enormous number of stars into a relatively small space. This makes them appear unusually bright for their size, which can sometimes cause them to be misclassified as other types of celestial objects. Some of the objects currently labeled as globular clusters, dense collections of stars orbiting galaxies, may actually be hypercompact stellar systems in disguise. This raises a fascinating possibility. Could some of the objects orbiting the Milky Way itself be hypercompact stellar systems? If so, that would suggest that our galaxy has, at some point in its past, absorbed or interacted with another galaxy in a way that left behind one of these high-speed remnants. To understand what this would mean, we have to consider the long-term future of the Milky Way. Astronomers predict that in about 4.5 billion years, our galaxy will collide with the Andromeda Galaxy in a slow-motion crash that will last for millions of years. When this happens, the two galaxies will merge into a single, much larger structure. But not every part of each galaxy will survive the collision. Some stars will be thrown out into intergalactic space, forming new streams of stars that drift through the cosmos. Others may be pulled into the growing central core of the new galaxy. And it's entirely possible that the violent interaction could create new hypercompact stellar systems, small, fast-moving remnants that are ejected from the merged galaxy entirely. If this happens, then in the distant future, there could be hypercompact stellar systems that originated from the Milky Way itself, fragments of our galaxy, carrying some of its oldest stars, sent hurtling through the void at unimaginable speeds. But here's where things get even stranger. If hypercompact stellar systems are created through galaxy mergers, then they may also be linked to another mysterious phenomenon: rogue supermassive black holes. Every large galaxy is thought to contain a supermassive black hole at its center. But what happens to these black holes when galaxies collide? In some cases, the black holes from each galaxy may merge, forming an even larger black hole at the center of the new galaxy. But in other cases, the gravitational interactions may cause one of the black holes to be ejected, sending it flying into intergalactic space as a rogue black hole. Some astronomers believe that these rogue black holes are more common than we realize. If a hypercompact stellar system is ejected from a galaxy, and if that system contains a central black hole, then we would expect to find rogue black holes traveling through space at high speeds. These objects would be nearly impossible to detect because they don't emit light. They only reveal themselves through their gravitational influence on nearby objects. But what if one of these rogue black holes were to pass close to another galaxy? Could it disrupt the stars within that galaxy, creating new streams of ejected material? Could it even trigger the formation of new hypercompact stellar systems by interacting with the dense cores of other galaxies? The possibility of rogue black holes moving through intergalactic space is one of the most unsettling ideas in modern astrophysics. These objects could be drifting silently through the universe, undetectable except for the occasional distortions they create in the fabric of space-time. Some astronomers believe that we've already found hints of these objects in the form of unexplained stellar movements, stars that appear to be orbiting something massive yet invisible. If true, then hypercompact stellar systems may not only be remnants of galactic destruction but also signposts pointing us toward an even greater cosmic mystery: the hidden population of wandering black holes. But what about the stars within these systems? One of the most intriguing aspects of hypercompact stellar systems is the fact that their stars are packed together so tightly. This extreme density means that the interactions between stars in these systems are much more frequent than in ordinary galaxies. In a normal galaxy, stars are so far apart that they almost never collide. But in a hypercompact stellar system, where stars are crammed into a tiny volume, the chances of stellar collisions are much higher. This could lead to the formation of exotic objects like blue stragglers, stars that appear younger and hotter than the surrounding population because they have merged with another star. It could also lead to the formation of new black holes as massive stars in the system collide and collapse. Even more interesting is the possibility that some of these systems might contain planets. If planets exist in hypercompact stellar systems, they would experience an environment unlike anything we see in our own galaxy. The night sky on a planet in one of these systems would be filled with brilliant stars packed closely together, creating a sky far brighter than anything seen from Earth. The intense gravitational forces within the system could also cause strange orbital dynamics, leading to planets with wildly unstable orbits. If life could exist in such an extreme environment, it would have to adapt to conditions that are entirely different from anything we know. A planet in a hypercompact stellar system might be bombarded with radiation from nearby stars, experience chaotic gravitational shifts, and be at constant risk of being ejected from the system entirely. Could life survive in such a place? And if so, would it evolve in a completely different way from life on Earth? These are the kinds of questions that make hypercompact stellar systems one of the most exciting topics in modern astrophysics. They challenge our understanding of galaxies, black holes, and the fundamental processes that shape the universe. And as we continue to search for these systems, we may find that they hold the key to answering some of the biggest mysteries in cosmology. For now, we can only continue to look. New telescopes and observational techniques may finally allow us to detect more of these elusive objects. And when we do, we may find that the universe is filled with far more hypercompact stellar systems than we ever imagined. They are the last remnants of galaxies that no longer exist. They are the footprints of cosmic destruction. They are the echoes of galactic battles that played out millions or even billions of years ago. And they are out there, moving silently through the darkness, waiting to be discovered. The search for hypercompact stellar systems is still in its early stages, but as technology improves, astronomers are getting better at detecting these elusive objects. One of the biggest breakthroughs in this effort has come from the use of advanced telescopes equipped with highly sensitive instruments capable of measuring the movements and properties of distant celestial bodies. Space telescopes like Hubble and ground-based observatories like the Very Large Telescope, VLT, have played a crucial role in identifying potential candidates. But the real game-changer is expected to be the James Webb Space Telescope, JWST, and future observatories like the Extremely Large Telescope, ELT. These next-generation telescopes have the ability to peer deeper into space than ever before, allowing scientists to detect the faint traces of hypercompact stellar systems that may have been overlooked in previous surveys. By analyzing the way these objects move, astronomers can determine whether they are traveling at the extreme speeds expected of a hypercompact stellar system. If they find a compact cluster of stars moving at thousands of kilometers per second relative to their surroundings, it could be the smoking gun evidence needed to confirm more of these systems. One of the most exciting aspects of this search is that hypercompact stellar systems may not be as rare as we once thought. Because they are small and fast-moving, they could be hiding in plain sight, misclassified as other types of star clusters or even as individual stars. The challenge is distinguishing them from other high-velocity objects in space, such as runaway stars or remnants of smaller galaxies. To do this, astronomers rely on spectroscopy, a technique that breaks down the light from an object into its component wavelengths. By analyzing the spectral signature of a suspected hypercompact stellar system, scientists can determine its composition, temperature, and movement. If the system contains an unusual concentration of old, metal-rich stars and exhibits rapid motion, it strengthens the case that it is indeed a hypercompact stellar system rather than a different type of stellar cluster. Another method used to detect these systems involves gravitational lensing. This phenomenon occurs when a massive object, such as a galaxy or black hole, bends and magnifies the light from a more distant object behind it. If a hypercompact stellar system passes in front of a background galaxy or quasar, it could create a temporary brightening effect that reveals its presence. This technique has been used to discover exoplanets and distant galaxies, and it may also prove useful in uncovering more hypercompact stellar systems. But even with these advanced techniques, there is still much we don't know about these mysterious objects. For example, what happens to the supermassive black holes that originally anchored the galaxies they came from? In some cases, the black hole may be ejected along with the stellar system, creating a wandering black hole that drifts through space with a cluster of stars around it. In other cases, the black hole may remain behind in the original galaxy, while the hypercompact stellar system is flung outward on its own. If there are rogue black holes traveling through space with hypercompact stellar systems, they could have profound implications for our understanding of black hole physics. These systems could act as natural laboratories for studying how black holes interact with stars in an environment very different from the crowded centers of galaxies. They could also provide clues about how often black holes are ejected from galaxies, and whether they pose any potential risks to other star systems. Another question that remains unanswered is what ultimately happens to hypercompact stellar systems over long timescales. Do they continue traveling through intergalactic space indefinitely, or do they eventually slow down and merge with other galaxies? If they do merge, what impact do they have on their new host galaxies? Could they trigger new waves of star formation, or do they remain as isolated relics of past galactic collisions? Some theories suggest that hypercompact stellar systems could eventually disperse over billions of years, with their stars gradually drifting apart due to gravitational interactions. Others propose that they may remain intact for much longer periods, held together by their own internal gravity and the potential presence of a central black hole. If hypercompact stellar systems can survive for billions of years, it raises another intriguing possibility. Could they serve as safe havens for civilizations that want to escape the dangers of larger galaxies? In a normal galaxy, planets and stars are constantly at risk from cosmic events like supernovae, gamma-ray bursts, and black hole interactions. But in a hypercompact stellar system, the absence of surrounding galactic activity could create a more stable environment for life to thrive. Of course, the conditions within these systems would still be extreme. With stars packed so closely together, radiation levels would likely be much higher than in a normal galactic environment. Any planets that exist within these systems would need to have strong magnetic fields or thick atmospheres to protect against the intense radiation. But if life could adapt to these conditions, it might find itself in a truly unique setting, one where the night sky is filled with brilliant, closely packed stars, and where the gravitational forces at play create an entirely different set of physical challenges. If intelligent life ever arose in a hypercompact stellar system, how would it perceive the universe? Would it be able to see beyond its own dense cluster of stars, or would the bright glow of nearby suns obscure the view of the cosmos? Would such a civilization develop differently from one in a more open star system like our own? These are the kinds of questions that make hypercompact stellar systems such a fascinating topic. They challenge our assumptions about the structure of the universe and open up new possibilities for what we might find as we continue to explore the cosmos. With each new discovery, we get closer to understanding the true nature of these systems. Future missions, such as the planned Nancy Grace Roman Space Telescope, could provide even more insights by conducting deep surveys of the universe and identifying more of these high-speed stellar remnants. As technology advances, we may even be able to send probes or telescopes closer to suspected hypercompact stellar systems to study them in greater detail. For now, they remain one of the most intriguing and least understood aspects of astrophysics, a reminder that the universe is full of surprises, and that some of its greatest mysteries are still waiting to be uncovered. Hypercompact stellar systems challenge our understanding of how galaxies evolve and interact with each other. These mysterious, high-speed stellar remnants push the limits of what we thought was possible when galaxies collide, merge, and sometimes violently separate. While astronomers are still piecing together their full story, one thing is clear: these systems are more than just cosmic anomalies. They represent an entirely new class of astronomical objects, and their existence raises profound questions about the fate of galaxies, black holes, and even the nature of the universe itself. One of the most pressing questions is just how many hypercompact stellar systems exist. Because they are small, faint, and fast-moving, they could be far more common than we currently recognize. Some astronomers estimate that there could be thousands or even millions of these objects scattered throughout the cosmos, hiding in plain sight. The reason we haven't found more of them yet is simply that they are incredibly difficult to detect. A key challenge is their extreme velocity. Most stars and galaxies follow predictable movements, orbiting in stable paths dictated by gravity. Hypercompact stellar systems, on the other hand, behave in a way that defies normal expectations. They move at thousands of kilometers per second, often on trajectories that take them far away from any recognizable galactic structure. This high velocity means they can quickly travel vast distances, making it harder to track their origins. Another challenge is their size. Unlike normal galaxies, which contain hundreds of billions of stars, hypercompact stellar systems are much smaller. They may contain only a few million stars, which is still an impressive number, but nowhere near enough to make them as visible as larger galactic structures. From Earth, they often appear as tiny, faint clusters of light, easily mistaken for distant star clusters or even individual stars. This means that many hypercompact stellar systems may already be sitting in astronomical data, unnoticed or misclassified. Some astronomers believe that by re-examining past observations with more advanced techniques, we could uncover many more of these elusive objects. New AI-powered algorithms are being developed to sift through massive amounts of telescope data, searching for the telltale signs of hypercompact stellar systems. These include unusual motion patterns, tightly packed groups of stars, and unexpected shifts in velocity. One of the most promising methods for detecting hypercompact stellar systems is through their interactions with the cosmic microwave background, CMB. The CMB is the faint radiation left over from the Big Bang, and it serves as a sort of cosmic backdrop for everything in the universe. When objects move at extremely high speeds, they can create subtle distortions in this background radiation, similar to the way a boat moving through water creates ripples. If hypercompact stellar systems are as common as some astronomers suspect, they could be creating these small but detectable distortions all over the sky. Another avenue of exploration is gravitational wave astronomy. When massive objects move or collide, they create ripples in the fabric of space-time, known as gravitational waves. The detection of gravitational waves has already revolutionized our understanding of black holes and neutron stars, but it may also help us find hypercompact stellar systems. If one of these systems passes close to another massive object, such as a galaxy or another black hole, it could create detectable gravitational wave signals, revealing its presence. As more hypercompact stellar systems are discovered, scientists will be able to analyze their distribution and behavior on a much larger scale. This could help answer fundamental questions about how galaxies evolve and what happens when they interact in violent cosmic collisions. It could also provide insights into how often supermassive black holes are ejected from galaxies, and what role these rogue black holes play in shaping the universe. One of the most mind-bending possibilities is that hypercompact stellar systems may represent the remnants of galaxies that were completely destroyed. In most galaxy collisions, the two merging galaxies will eventually settle into a new, larger structure. But in some cases, the collision could be so violent that one galaxy is essentially torn apart, leaving behind nothing but a small core of stars moving at extreme speeds. If this is true, then hypercompact stellar systems could be the last survivors of ancient, long-lost galaxies that no longer exist. This raises another fascinating question. What if our own Milky Way were to experience a collision that resulted in the creation of a hypercompact stellar system? If our galaxy were to merge with another large galaxy, such as Andromeda, which it is on a collision course with, could a small remnant of stars be ejected at high speed, forming a hypercompact stellar system? And if so, what would it be like for any potential life forms that might exist in that system? Imagine a civilization that finds itself inside a hypercompact stellar system, hurtling through space at thousands of kilometers per second. Would they even be aware of their extraordinary motion, or would it seem normal to them? Would they be able to see their home galaxy drifting away in the distance, or would their night sky remain unchanged? The idea of intelligent life surviving in such an extreme environment is purely speculative, but it's the kind of question that makes hypercompact stellar systems so intriguing. The study of hypercompact stellar systems also has implications for the search for dark matter. Dark matter is one of the greatest mysteries in modern physics. It makes up most of the mass in the universe, yet it doesn't emit, absorb, or reflect light, making it nearly impossible to detect directly. Scientists can only infer its presence by observing its gravitational effects on visible matter. Some researchers believe that hypercompact stellar systems could act as unique test environments for studying dark matter, as their high velocities and isolated nature could make them ideal laboratories for detecting subtle gravitational interactions that might reveal new clues about this hidden substance. Another possibility is that hypercompact stellar systems could help us understand the ultimate fate of the universe. If these systems can remain intact for billions of years, drifting through intergalactic space, then they could serve as some of the last structures to exist as the universe continues to expand. In the far future, when galaxies have stopped forming and the universe has become a vast, cold, empty expanse, hypercompact stellar systems could still be out there, wandering through the darkness, carrying the last remnants of stellar light. There is still so much we don't know about these mysterious objects, but one thing is certain: hypercompact stellar systems are a crucial piece of the cosmic puzzle. As we continue to develop new technologies and refine our methods of observation, we are bound to uncover more of these high-speed remnants, and with them, new insights into the nature of galaxies, black holes, and the universe itself. Every discovery we make about hypercompact stellar systems brings us closer to answering some of the biggest questions in astrophysics. Are they common or rare? Do they contain black holes? How do they evolve over time? And perhaps most intriguingly, could they one day serve as homes for life, drifting endlessly through the cosmos? The search for these objects is just beginning, and the next few decades promise to be an exciting time for astronomers. With better telescopes, more powerful simulations, and new observational techniques, we may soon uncover the full story of hypercompact stellar systems. Until then, they remain one of the most fascinating unsolved mysteries of space, reminders that the universe still holds secrets waiting to be revealed. Hypercompact stellar systems are more than just high-speed remnants of galactic collisions. They might be key to understanding the dynamic forces that shape the universe. Their very existence challenges conventional ideas about how galaxies interact, what happens to black holes when galaxies merge, and whether these objects could be far more common than we currently realize. One of the biggest mysteries surrounding hypercompact stellar systems is their long-term fate. Given their extreme velocities, these systems are not gravitationally bound to any galaxy, meaning they travel through intergalactic space indefinitely. But what happens to them over billions of years? Do they eventually slow down? Do they interact with other cosmic structures? Could they even serve as the building blocks of entirely new galaxies in the distant future? To answer these questions, scientists are developing computer simulations that model the motion and evolution of hypercompact stellar systems. These simulations take into account the gravitational forces acting on these systems as they move through the cosmos, as well as the possible influence of dark matter. The results so far suggest that most hypercompact stellar systems will remain isolated for the rest of cosmic history, drifting through the vast emptiness between galaxies. However, in some rare cases, a hypercompact stellar system might encounter another galaxy or another high-speed stellar system. When this happens, there are several possibilities. The system could be gravitationally captured by the new galaxy, becoming an unusual satellite cluster orbiting the main galactic structure. Alternatively, it could experience another strong gravitational interaction, flinging it off in an entirely new direction at even higher speeds. There's also the possibility that hypercompact stellar systems could collide with each other. While the chances of this happening are extremely low due to the vast distances between them, if two such systems were to pass close enough, their mutual gravity could cause them to merge into a larger cluster. This raises the intriguing question of whether hypercompact stellar systems could slowly accumulate stars and grow into something more significant over time. Could they evolve into mini-galaxies? Could they serve as the seeds of entirely new cosmic structures? One of the most exciting aspects of studying hypercompact stellar systems is the potential for unexpected discoveries. Every time astronomers have thought they had a complete understanding of how galaxies and black holes behave, new observations have forced them to rethink their theories. The discovery of hypercompact stellar systems is already rewriting what we thought we knew about the dynamics of galactic mergers, and it's likely that future studies will reveal even more surprises. For example, could there be different types of hypercompact stellar systems? Most of the ones discovered so far appear to be remnants of galactic mergers that involve supermassive black holes. But what if similar systems could form under completely different circumstances? Could there be hypercompact stellar systems that don't contain black holes at all, but are instead made up of highly dense clusters of stars ejected from violent cosmic events? Some astronomers speculate that certain hypercompact stellar systems could even be remnants of much older cosmic structures, perhaps the last survivors of ancient galaxies that existed in the early universe. If this is true, then studying these systems could give us direct insight into what the cosmos looked like billions of years ago, offering a rare glimpse into the past. Another fascinating possibility is that hypercompact stellar systems could be responsible for some of the unexplained cosmic phenomena we observe. For instance, could some of the mysterious fast-moving objects detected in deep space actually be undiscovered hypercompact stellar systems? Could their motion explain some of the unexplained gravitational lensing effects we've seen? Additionally, hypercompact stellar systems might play a role in the spread of life across the universe. If any planets exist within these systems, they would be carried along at extreme speeds, potentially traveling vast distances across intergalactic space. This raises the mind-blowing question: could hypercompact stellar systems serve as natural spaceships for microbial life, carrying the building blocks of life from one part of the universe to another? This idea is related to a controversial hypothesis known as panspermia, which suggests that life may spread through space via asteroids, comets, and other celestial bodies. If hypercompact stellar systems contain planets, or even just debris with organic compounds, then they could potentially transport life over unimaginable distances, seeding new star systems and planets in the process. There's still so much we don't know, and every discovery brings new questions. What if some hypercompact stellar systems are moving so fast that they are completely escaping the gravitational pull of the observable universe? Could these objects be messengers from other cosmic regions beyond what we can currently see? One of the biggest technological advances that could help answer these questions is the next generation of space telescopes. Instruments like the James Webb Space Telescope and future gravitational wave observatories are expected to revolutionize our ability to detect and study faint, fast-moving objects like hypercompact stellar systems. With better sensitivity and more advanced detection methods, astronomers could soon confirm whether these systems are rare oddities or a fundamental feature of the cosmos. Another game-changing tool could be the study of rogue black holes. Scientists have long suspected that there are countless black holes wandering through intergalactic space, ejected from galaxies just like hypercompact stellar systems. If we can find more of these rogue black holes and compare their locations to known hypercompact stellar systems, we might be able to piece together a clearer picture of how these objects form and evolve. Perhaps one of the most mind-bending possibilities is that hypercompact stellar systems could be used in the far future for interstellar travel. If humanity ever reaches a point where we can harness advanced propulsion technologies, a hypercompact stellar system could serve as a cosmic vehicle, naturally traveling at incredible speeds. Could future civilizations find a way to hitch a ride on one of these high-speed clusters, using it to travel across the vast distances between galaxies? Of course, this remains purely speculative, but the fact that such ideas even exist is a testament to how mysterious and fascinating hypercompact stellar systems truly are. They challenge our understanding of black holes, galaxies, and cosmic motion itself, and they open up entirely new questions about what is possible in the universe. As research continues, hypercompact stellar systems may reveal secrets about the early universe, the nature of gravity, and the hidden forces that shape the cosmos. They remind us that the universe is still full of surprises and that some of the most profound discoveries may still be waiting to be made. The search for more of these elusive objects is just beginning, and as technology advances, we may find that hypercompact stellar systems are far more common, and far more important, than we ever imagined. If hypercompact stellar systems turn out to be widespread, it would mean that galaxies have been flinging these high-speed clusters into intergalactic space for billions of years. That realization alone could change our understanding of galactic evolution. It would imply that whenever two galaxies collide, they don't just merge into a larger system but also leave behind a hidden trail of stars speeding off in all directions. Think about that for a moment. The Milky Way itself is on a collision course with the Andromeda Galaxy, and when that merger happens in a few billion years, it's likely that some stars, perhaps even entire clusters, will be ejected as hypercompact stellar systems. If there are planetary systems within those clusters, they'll be sent on a one-way journey into the void, forever drifting between galaxies. This raises another fascinating question: what happens to planets and potential life in these systems? A hypercompact stellar system is not just a single star, it's an entire cluster of stars. That means if planets exist in these systems, they would be experiencing a journey unlike anything else in the universe. Imagine a planetary system that was once part of a normal galaxy, orbiting a stable star in a dense stellar neighborhood. Then, due to an unimaginable cosmic event, the entire system is ripped away and launched into deep space. Over millions or even billions of years, that system continues traveling at extreme speeds, far from any galaxy, with only the distant glow of background stars in every direction. For any life that may exist on such a planet, the view of the night sky would change dramatically. Over time, the familiar constellations would vanish as the system drifts farther from any recognizable stellar formations. The universe itself would appear lonelier. But would life survive such a journey? Without the gravitational influence of a massive galaxy, would planetary orbits remain stable, or would the chaotic forces of interstellar space eventually disrupt them? Some scientists speculate that if a hypercompact stellar system retains enough of its original structure, planets could continue orbiting their stars without much disturbance. In that case, life could theoretically persist in these high-speed star clusters, shielded from the chaos of galactic mergers and supernovae. If these systems truly are abundant, they could even be some of the best places to search for stable, long-term habitable planets. This brings up the possibility of hypercompact stellar systems acting as cosmic lifeboats. If a civilization in a galaxy knew that a catastrophic event, like a supernova explosion or black hole collision, was about to occur, could they somehow relocate to a hypercompact stellar system and hitch a ride out of the galaxy? The idea is highly speculative, but in a universe full of extremes, it's not entirely impossible. There's also a more disturbing possibility. What if hypercompact stellar systems are actually evidence of an unknown cosmic process that we don't yet understand? What if these high-speed clusters are not just the result of galactic mergers, but something else entirely? Could there be an unseen force in the universe ejecting these systems for reasons we haven't yet discovered? Some astronomers have proposed that in rare cases, extremely powerful gravitational interactions, perhaps involving yet undiscovered cosmic structures, could create hypercompact stellar systems in ways that don't involve galaxy mergers. For example, if an unknown type of dark matter halo or an exotic gravitational anomaly exists in deep space, could it be flinging these systems outward at high speeds? Could there be an unseen cosmic mechanism that is shaping the structure of the universe in ways we haven't yet realized? This might sound like science fiction, but history has shown that the universe is full of surprises. Less than a century ago, we didn't even know other galaxies existed. The idea that stars could be flung from galaxies at incredible speeds was once considered impossible. Now we know not only that it happens, but that entire star clusters, containing thousands or even millions of stars, can be ejected in one violent motion. And that raises perhaps the most unsettling question of all. Could something far more massive than a hypercompact stellar system be ejected in the same way? Could entire mini-galaxies, or even black holes, be speeding through intergalactic space without us knowing? There's already some indirect evidence that rogue supermassive black holes exist. These black holes, ejected from galactic centers due to violent mergers, may be traveling across the universe completely undetected. If hypercompact stellar systems are the smaller cousins of these rogue black holes, then studying them could give us clues about a much larger and more terrifying phenomenon: entire cosmic structures being thrown across space like celestial bullets. The search for more hypercompact stellar systems is still in its infancy, but new technologies will make discoveries more frequent. Future space telescopes, like the Nancy Grace Roman Space Telescope, will have the ability to scan large areas of the sky with incredible precision, making it easier to identify faint, fast-moving clusters. Additionally, upcoming gravitational wave detectors might be able to detect the ripples in spacetime caused by the violent ejection of these systems. In the coming decades, we may learn that hypercompact stellar systems are a common feature of the universe, lurking between galaxies in numbers far greater than we ever imagined. Or we may discover that they are even rarer than we thought, an exotic, one-in-a-billion occurrence that only happens under extreme conditions. Either way, the study of these systems will continue to push the boundaries of what we know about the cosmos. And as we uncover more about these high-speed clusters, we may begin to see them not as mere remnants of galactic destruction, but as cosmic travelers, ancient, mysterious, and possibly even carrying secrets from the earliest days of the universe. If hypercompact stellar systems are truly cosmic travelers, then they may hold clues about events that happened billions of years ago, events that shaped the universe as we know it. Since these clusters move at such high velocities and exist outside of traditional galaxies, they could serve as time capsules, preserving evidence of conditions that existed in their original galaxies before they were ejected. One of the biggest mysteries in astrophysics is how the first galaxies formed and evolved. We know that galaxies grew over time through collisions and mergers, but studying the early universe is difficult because the light from those ancient times has been stretched and dimmed by cosmic expansion. However, hypercompact stellar systems might provide a different kind of record. If some of these clusters originated billions of years ago and were ejected early in their host galaxy's history, they could contain stars that formed in the very first generations of cosmic evolution. If astronomers could study these systems up close, they might be able to analyze their chemical composition and determine whether they contain unusually old stars, possibly among the first stars ever formed. This could help answer fundamental questions about how galaxies build themselves, how early stars synthesized heavy elements, and whether the universe was more chaotic in its infancy than we currently understand. But beyond their historical significance, hypercompact stellar systems also challenge our assumptions about how stars behave in different environments. Normally, stars exist within galaxies, where they are affected by the gravitational pull of billions of other stars, as well as by the presence of dark matter. But in hypercompact stellar systems, the stars are largely isolated from these influences. They are no longer bound to a galaxy's spiral arms or central bulge. Instead, they move through the universe in a way that's entirely dictated by their own internal gravity and momentum. This makes them a kind of natural experiment, an opportunity to see how stars interact when they are removed from the typical galactic environment. For example, we know that galaxies contain large amounts of gas and dust that can influence star formation, but hypercompact stellar systems are stripped of this material. What happens to the stars in these systems over long periods of time? Do they evolve differently? Do they have a higher or lower chance of forming planets? Could they be more stable than stars within galaxies, since they are free from the disruptive forces of galactic collisions and supernova shockwaves? And speaking of planets, one of the biggest questions is whether any planets exist within these high-speed clusters. If planets do exist in hypercompact stellar systems, they would be experiencing a journey unlike anything we've ever imagined. A planet in such a system wouldn't just be orbiting its star, it would be traveling through the universe at incredible speeds, moving away from its home galaxy forever. If intelligent life existed on such a planet, it would be experiencing a completely different reality from anything we've ever known. Imagine an advanced civilization developing on a world inside a hypercompact stellar system. At first, they might believe that their local star cluster is the entire universe. But over time, as their technology advanced, they might notice that they are moving away from all other galaxies. Their night sky would change as the background stars slowly faded into the distance. They would see no evidence of a larger galactic structure around them. To them, the universe would appear mostly empty. Would they even realize that galaxies exist? Or would they believe that the entire cosmos is just their small collection of stars drifting through space? This is a mind-bending thought because it raises the possibility that intelligent civilizations could exist in the universe without ever knowing about the true nature of galaxies, clusters, or cosmic expansion. They would be completely isolated, living within a high-speed stellar island, unaware that they were once part of something much larger. But what if the opposite is true? What if civilizations in hypercompact stellar systems are actually at an advantage? Since they are not gravitationally bound to a galaxy, they might be less vulnerable to cosmic disasters like supernovae, gamma-ray bursts, or even black hole mergers. Their environment might be more stable over long periods, giving life more time to develop without interference. In that case, could hypercompact stellar systems actually be some of the best places in the universe for life to thrive? Could they be the ideal refuge for advanced civilizations that want to avoid the chaos of galaxies? If so, then searching for planets in these systems might be one of the most exciting areas of future astronomy. The challenge, of course, is detecting planets in such extreme environments. Since these systems are moving at such high speeds, it might be difficult to use traditional planet hunting techniques like the transit method, which relies on detecting small dips in a star's brightness when a planet passes in front of it. But new observational techniques, such as gravitational microlensing, might make it possible to detect planets even in these unusual locations. And if planets are found in hypercompact stellar systems, the next step would be to determine whether they have atmospheres, liquid water, or other conditions necessary for life. This could lead to one of the biggest discoveries in human history, the realization that life can exist in places we never thought possible, far outside the traditional boundaries of galaxies. But there's another question we have to consider. If hypercompact stellar systems are so different from the rest of the universe, could they contain forms of life that are completely unlike anything we've ever imagined? Could the unique conditions of these systems create biological processes that operate under entirely different rules? Could alien life in these clusters have evolved in ways that would be unrecognizable to us? Some astrobiologists have speculated that if life does exist in extreme environments, such as rogue planets, deep interstellar space, or high-speed star clusters, it might not follow the same biochemical principles as life on Earth. Instead of relying on carbon-based molecules and water, life in these systems might have adapted to conditions of extreme radiation, low gravity, or unpredictable stellar environments. In that case, hypercompact stellar systems might be home to some of the strangest, most exotic forms of life in the universe. Life that developed without the influence of a galaxy's gravitational field. Life that never knew the concept of a home galaxy. Life that has been traveling for billions of years, cut off from all other civilizations, living in eternal motion. If we ever find evidence of such life, it would completely change our understanding of what is possible in the universe. It would mean that life isn't just something that happens on stable planets, orbiting sun-like stars within large galaxies. It would mean that life can persist even in the most extreme conditions, hurtling through space at unimaginable speeds, forever drifting between the stars. And that raises one final question. If hypercompact stellar systems can contain planets, and if some of those planets can support life, then what if one of these systems is heading toward us? What if, somewhere out there in the vastness of intergalactic space, a high-speed cluster of stars is on a collision course with our own galaxy? We already know that the Milky Way is on track to collide with Andromeda in a few billion years. But what if, long before that happens, a hypercompact stellar system comes speeding into our galactic neighborhood? Would we even see it coming? Could it pass through our galaxy without being noticed? Or would its gravitational influence disrupt nearby stars, altering planetary orbits and causing chaos in ways we can't yet predict? These are the kinds of mysteries that keep astronomers awake at night. Because the truth is, the universe is far stranger than we ever imagined. And hypercompact stellar systems are just one more piece of the puzzle, one more reminder that the cosmos is full of surprises, waiting to be uncovered. The idea of a hypercompact stellar system hurtling toward us may sound like something out of science fiction, but in reality, it's not entirely impossible. The universe is full of movement, galaxies colliding, stars being ejected, and black holes slingshotting objects at incredible speeds. If a hypercompact stellar system were on a trajectory toward the Milky Way, what would happen? First, it's important to understand that space is vast. Even though galaxies appear to be packed with stars, the distances between them are so enormous that even if a hypercompact stellar system passed through our galaxy, the chances of a direct collision with a star system like ours would be incredibly low. But that doesn't mean it wouldn't have an impact. The gravitational pull of such a system could still disrupt star orbits, altering the stability of planetary systems in its path. If such a cluster approached our solar system, the effects could be subtle at first, small shifts in the orbits of distant objects like the Oort cloud, where countless icy bodies reside at the farthest edges of our solar system. Over time, those shifts could send comets hurtling inward, increasing the likelihood of impacts on Earth and other planets. But what if a hypercompact stellar system didn't just pass through? What if, by some extraordinary chance, our solar system became gravitationally bound to it? Could our Sun and its planets be captured by this high-speed cluster and flung out into intergalactic space? Theoretically, if the conditions were right, if the gravitational forces aligned in just the right way, our entire solar system could be dragged along with it, torn from the Milky Way and sent on an eternal journey through the void. Imagine that, an entire civilization, completely unaware, moving away from its home galaxy, drifting further and further into the darkness of intergalactic space. This might sound terrifying, but in reality, the likelihood of such an event is incredibly low. The Sun is gravitationally anchored within the Milky Way's disk, and escaping the galaxy entirely would require a tremendous amount of energy. However, that doesn't mean smaller systems, rogue planets, asteroids, or even spacefaring civilizations couldn't be influenced by these high-speed clusters. If we think about hypercompact stellar systems as cosmic nomads, then the question becomes, could they be carrying something with them? Could they be transporting the remnants of long-lost civilizations, the debris of ancient alien worlds, or even artificial structures built by advanced beings? Consider this: if an intelligent civilization once lived in a galaxy that was torn apart by a supermassive black hole merger, and if their home was ejected as part of a hypercompact stellar system, then their technology, if it survived, could now be traveling through intergalactic space at an incredible velocity. Could we one day detect the remnants of such a civilization, scattered across the stars, waiting to be discovered? Some scientists have speculated that advanced civilizations, if they ever reached a point where they could predict their galaxy's destruction, might try to escape by launching artificial habitats into space. What if hypercompact stellar systems aren't just natural star clusters? What if some of them contain the ruins of civilizations that tried to outrun their fate? This brings us to another mind-bending question: could hypercompact stellar systems serve as a kind of intergalactic transport system? Could future spacefaring civilizations intentionally use these high-speed clusters as a way to travel between galaxies? If a civilization could establish a base on a planet within a hypercompact stellar system, it would have a unique advantage. It would already be traveling at incredible speeds. Instead of developing traditional starships that take centuries to cross interstellar distances, they could simply hitch a ride on a natural high-speed system, using it to reach other galaxies far faster than conventional space travel would allow. Theoretically, a highly advanced civilization could even modify the trajectory of a hypercompact stellar system, using megastructures to alter its path and direct it toward a specific destination. Imagine a scenario where an alien race harnesses the energy of a central black hole remnant, using it to generate propulsion that steers an entire star cluster. This would be the ultimate form of cosmic engineering, a civilization literally moving an entire system of stars through space like a giant spacecraft. But if such civilizations exist, where are they? Could they be hidden within the hypercompact stellar systems we have yet to detect? Could some of these clusters contain evidence of intelligent design, signals, artificial structures, or patterns that suggest they have been manipulated by unknown forces? Some scientists have suggested that if we ever find a hypercompact stellar system that appears to be moving in an unusually precise way, following a trajectory that doesn't match our models of natural gravitational interactions, it might be a sign that something artificial is guiding it. If that were the case, it would be the biggest discovery in the history of astronomy, the first evidence that intelligent life has harnessed the power of entire star systems. Of course, this is all speculation. But speculation is what drives scientific discovery. We didn't know about exoplanets until we started looking for them. We didn't know about black holes until we found indirect evidence of their existence. And now, with new telescopes capable of peering deeper into space than ever before, we might be on the verge of discovering the true nature of hypercompact stellar systems. What we do know is that these systems are out there. They exist. And they defy our understanding of how galaxies, stars, and gravity interact. They are among the fastest moving objects in the universe, and yet, for now, they remain largely hidden, drifting through the cosmos like ghosts from another era. If we can unlock their secrets, we may not only learn more about the past of the universe, we may glimpse its future. We may discover new ways to travel between the stars, new forms of life, or even new civilizations that have been waiting for us to find them. And if, one day, we detect a hypercompact stellar system heading toward us, we'll have to ask ourselves, is it just another rogue cluster, wandering aimlessly through space? Or is it something more? Is it a message? A vessel? A warning? The truth is, we don't know. But what we do know is that the universe is full of mysteries. And hypercompact stellar systems may be one of the strangest, most exciting enigmas we have yet to unravel. Hypercompact stellar systems challenge everything we thought we knew about the way stars behave. These high-speed clusters exist in the vast emptiness of intergalactic space, traveling at breakneck speeds, ripped from their home galaxies by the chaotic forces of merging supermassive black holes. But what makes them so fascinating is not just their speed, it's their resilience. Think about it. A hypercompact stellar system is a group of stars that somehow manages to stay gravitationally bound together despite being launched out of a galaxy at millions of miles per hour. This alone raises serious questions about the nature of gravity, the strength of stellar interactions, and even the way galaxies evolve. If these clusters are survivors of galactic destruction, could they be harboring other cosmic secrets? One of the biggest mysteries about these systems is their rarity. Why don't we see more of them? If supermassive black holes are merging across the universe, tearing apart galaxies and ejecting stars in the process, then hypercompact stellar systems should be everywhere. Yet, they seem to be incredibly difficult to detect. This could mean a few things. One possibility is that they do exist in large numbers, but they are simply too dim for us to see. After all, a small cluster of stars flying through space wouldn't have the same brightness as an entire galaxy. They could be hiding in plain sight, mistaken for distant stars or overlooked by our telescopes. Another possibility is that most hypercompact stellar systems don't survive for very long. Once they are ejected into intergalactic space, they might begin to slowly break apart. Without the gravitational influence of a galaxy to stabilize them, the stars could drift away from each other over millions of years, dissolving into isolated rogue stars scattered across the cosmos. But what if some of them don't dissolve? What if some remain intact, traveling through space for billions of years, carrying with them the last remnants of ancient, forgotten galaxies? Consider this. If a hypercompact stellar system formed billions of years ago, long before our galaxy even existed, then it could be a time capsule from the early universe. Its stars might be some of the oldest in existence, untouched by the gravitational chaos of galaxy formation. Studying them could provide a direct glimpse into the conditions of the cosmos when it was still young. This raises a compelling question: could hypercompact stellar systems be relics from the first generation of galaxies? Could they contain the fossils of the universe's earliest stars, stars that burned hot and fast before exploding in massive supernovae? If so, then these systems might not just be fast-moving clusters of stars. They could be keys to understanding how galaxies first formed, how the first black holes emerged, and how the universe evolved from a chaotic sea of energy into the vast cosmic landscape we see today. But there's another angle to consider. If hypercompact stellar systems are survivors of galactic destruction, then they could also contain something else: the shattered remains of planets. Imagine a planet orbiting a star within a galaxy that suddenly undergoes a violent merger event. As the black holes at the galaxy's center collide, stars are ripped from their orbits and flung into space. If that planet manages to stay gravitationally bound to its star, it would be ejected along with it, sent hurtling through intergalactic space at unimaginable speeds. What would happen to such a planet? Would it freeze in the absence of a nearby galaxy's heat? Would its atmosphere be stripped away by the radiation of intergalactic space? Or could it, against all odds, survive? A rogue planet within a hypercompact stellar system would be unlike anything we've ever encountered. It would be a world without a galaxy, without a home, drifting endlessly between the voids of existence. And if such a planet existed, could it still support life? It's easy to assume that a planet lost in intergalactic space would be lifeless. After all, it wouldn't receive heat from a nearby sun. But recent discoveries have challenged that assumption. Scientists now believe that some rogue planets that have been ejected from their home star systems, could still remain warm for billions of years due to geothermal activity. If a planet had a thick atmosphere or an internal heat source, it might be able to sustain liquid water beneath its surface, creating a hidden biosphere where life could persist even in the coldest depths of space. So, if hypercompact stellar systems contain rogue planets, and if those planets have internal heat, then it's not entirely impossible that life could exist on them. Could there be organisms, deep underground, living on a world that has been flying through space for eons, completely isolated from the rest of the universe? And if life could survive in such extreme conditions, could intelligent life do the same? Could there be civilizations out there that evolved on planets ejected from their home galaxies, forced to adapt to the isolation of deep space? The idea may sound unbelievable, but consider this: if intelligent life evolved on a planet that was part of a hypercompact stellar system, then they would have a unique understanding of the universe. Unlike us, who are bound to a stable galaxy and orbit a single star, they would have been born into a world that is always moving, always changing. They would have never known a home galaxy, never seen the familiar structure of the Milky Way in their night sky. Instead, their sky would be nearly empty. The closest galaxies would be faint smudges of light in the distance. They would live in near total darkness, surrounded by nothingness. How would that shape their perception of reality? Would they develop a completely different understanding of space, time, and existence itself? And if they became advanced enough, could they have found a way to communicate with other civilizations? Could they have sent out signals, desperate to find others in the void? Could we one day detect these signals, realizing that we are not alone, not just in our galaxy, but in the vast, uncharted emptiness between galaxies? It's a mind-bending idea, but it raises an even bigger question: if hypercompact stellar systems can travel between galaxies, and if they can potentially harbor planets, then could they be used as a means of intergalactic travel? Right now, the idea of humans leaving the Milky Way seems impossible. The distances are just too great. Even if we develop spacecraft capable of traveling at a fraction of the speed of light, it would still take millions of years to reach the nearest galaxies. But what if, instead of trying to travel between galaxies using traditional spacecraft, we found a way to hitch a ride on a hypercompact stellar system? If we could locate one that was on a trajectory that would eventually take it close to another galaxy, we could establish a long-term colony on one of its planets, or even build space stations around its stars. Over millions of years, we could slowly make our way across the void, using the natural movement of the system to bridge the impossible distances between galaxies. And if other civilizations out there have already figured this out, then hypercompact stellar systems could be more than just fast-moving star clusters. They could be highways through the cosmos, ancient trade routes connecting civilizations we have yet to discover. The truth is, we don't know what's out there. We don't know how many hypercompact stellar systems exist, how many of them contain planets, or whether any of them might hold the key to understanding our place in the universe. But what we do know is that these systems exist. They are real. And they are moving through the cosmos at unbelievable speeds, carrying with them the remnants of galaxies that no longer exist. If we can find them, study them, and unlock their secrets, we may not only discover new physics, new forms of life, or new ways to explore the universe, we may uncover the history of civilizations long gone, or even find a glimpse of our own future. Because if there's one thing we've learned from studying space, it's that nothing stays the same forever. Galaxies merge. Stars explode. Planets drift through the void. And somewhere out there, in the darkness between the galaxies, hypercompact stellar systems continue their endless journey, silent, mysterious, and waiting to be understood. Hypercompact stellar systems might hold the answers to some of the most profound questions in astrophysics, but they also challenge our very understanding of cosmic evolution. To truly grasp their significance, we have to consider what it means for a cluster of stars to be ejected from a galaxy at such extreme speeds. What forces are at play? What keeps them together despite the chaos of their creation? And most importantly, what does their existence tell us about the violent nature of the universe? One of the biggest mysteries surrounding hypercompact stellar systems is their formation. The leading theory suggests that they are the remnants of galaxies that have undergone a dramatic encounter with a supermassive black hole merger. When two galaxies collide, their central black holes spiral toward each other in an intense gravitational dance. As they get closer, they begin to interact with the surrounding stars in ways that defy intuition. The black holes act like slingshots, flinging stars away at incredible velocities. Most of these stars become hypervelocity stars, individual stars that are ejected from the galaxy, doomed to wander intergalactic space alone. But in rare cases, an entire cluster of stars can be caught in the chaos and launched together, forming a hypercompact stellar system. The key to their survival lies in their gravitational binding energy. Even as they are hurled into the void, the mutual gravitational attraction between the stars keeps them from dispersing immediately. This is what makes them different from hypervelocity stars, which typically travel alone. A hypercompact stellar system, despite being expelled at enormous speeds, retains its structure, at least for a while. But how long can they last? This is one of the biggest questions that astronomers are still trying to answer. Over time, as the stars interact with one another, gravitational perturbations could cause them to slowly drift apart. Some might be flung away, joining the ranks of lonely rogue stars. Others might remain bound, but in a looser, less structured form. The fate of these systems depends on their initial conditions, how tightly packed they were before ejection, how massive their individual stars are, and how strong their internal gravitational bonds remain. What's fascinating is that some hypercompact stellar systems might be incredibly ancient. If they were formed billions of years ago, during the early days of galaxy mergers, then they could be some of the oldest surviving structures in the universe. Their stars could contain valuable information about the chemical makeup of the early cosmos, revealing what elements were present when the first galaxies formed. This leads to an intriguing possibility. Could some of these systems be relics from the very first galaxies? If so, they might provide a direct link to the universe's infancy, allowing us to study the conditions that led to the formation of modern galaxies. Another perplexing aspect of these systems is their speed. Some hypercompact stellar systems have been found moving at speeds exceeding 1,000 kilometers per second, fast enough to eventually leave the gravitational pull of their home galaxy entirely. This raises the question, where are they going? In theory, some of them could be on trajectories that will take them deep into intergalactic space, never to return. Others, however, might be on paths that will eventually bring them into contact with other galaxies. If a hypercompact stellar system were to enter another galaxy, what would happen? Would it be captured by the galaxy's gravity and assimilated into its structure? Or would it pass through relatively undisturbed, continuing its lonely journey through the cosmos? There's also the question of dark matter. Galaxies are thought to be surrounded by vast halos of dark matter, an invisible substance that exerts gravitational influence but does not emit light. If hypercompact stellar systems travel through these halos, could they provide clues about the nature of dark matter? Could their movements be affected by unseen gravitational forces, giving us indirect evidence of what dark matter is made of? And then there's the question of black holes. If a hypercompact stellar system was ejected from a galaxy due to a supermassive black hole merger, is it possible that some of these systems contain their own black holes? Consider this scenario. A small galaxy with an intermediate mass black hole at its center collides with a larger galaxy. The gravitational forces at play cause the smaller galaxy to be torn apart, but instead of being completely consumed, a fragment of it, containing its central black hole, gets ejected. This fragment could become a hypercompact stellar system, but with one major difference: it would have a black hole at its core. If such a system existed, it would be unlike anything we've ever observed. A hypercompact stellar system with a central black hole would have an extremely strong gravitational field, which could keep its stars bound together for much longer than usual. Over time, The black hole might even accrete some of the surrounding stars, growing in mass and becoming more powerful. Could some of these systems be hidden mini-galaxies, containing not just stars, but black holes that continue to influence their evolution? If so, then they might not just be remnants of galactic destruction, they could be the seeds of new cosmic structures, waiting to grow into something much larger. But perhaps the most mind-bending idea is that some hypercompact stellar systems might not be natural at all. If an advanced civilization existed somewhere in the universe, and if they had the ability to manipulate gravity on a large scale, could they intentionally create such systems? Imagine a scenario in which an alien civilization, faced with the destruction of their home galaxy, decides to engineer their own escape. Instead of relying on individual starships, they could use gravitational engineering to bind a cluster of stars together and launch themselves into space as a self-sustaining system. This would solve many of the problems associated with interstellar travel. Rather than sending small ships into the unknown, they would be traveling with an entire ecosystem of stars and planets. If such a civilization existed, and if they had been traveling for millions or even billions of years, could they still be out there? Could hypercompact stellar systems be more than just stellar remnants? The more we learn about these systems, the more questions arise. How many of them are there? How long do they last? Do they contain planets? Could they support life? Could they even be used as a method of intergalactic travel? One thing is certain: hypercompact stellar systems are not just ordinary clusters of stars. They are cosmic anomalies, survivors of cataclysmic events, and possibly even gateways to deeper cosmic mysteries. If we can study them more closely, we may not only uncover new aspects of astrophysics, we may rewrite our entire understanding of how galaxies, black holes, and even life itself evolve in the universe. The cosmos is full of secrets, hidden in the vast darkness between the galaxies. Hypercompact stellar systems may be some of the rarest and most intriguing clues we have, offering a glimpse into forces that shape the universe on the grandest scales. As our technology improves and our ability to detect these systems grows, we may find that they are far more common than we ever imagined. And if that's the case, then who knows what else might be lurking out there, waiting to be discovered? The deeper we dive into the enigma of hypercompact stellar systems, the more we realize that their existence challenges some of our most fundamental ideas about the universe. If these systems are indeed the remnants of galaxies violently ejected by gravitational forces, then they might serve as cosmic fossils, recording the history of galaxy mergers, black hole interactions, and even the large-scale structure of the cosmos itself. One of the most baffling aspects of these systems is their sheer speed. Some hypercompact stellar systems move at velocities that defy conventional astrophysical expectations. To put this into perspective, the fastest stars in the Milky Way, known as hypervelocity stars, reach speeds of about 1,000 kilometers per second. But some of these stellar clusters are moving even faster than that, which means they were ejected with an unimaginable force. This raises an important question: is there a limit to how fast these systems can be ejected? Could there be clusters moving so fast that they escape not just their home galaxy, but even the gravitational influence of the entire universe? This is where things start getting really weird. There's a theoretical concept in physics called cosmic escape velocity. It refers to the idea that if something were to move faster than the expansion rate of the universe itself, it could, in theory, become completely unreachable, forever disappearing from our observable universe. Could some hypercompact stellar systems be moving so quickly that they are essentially being lost to the cosmos, flung beyond the limits of what we will ever be able to see? And if so, could they already contain planets, moons, or even life? Imagine a planet orbiting a star within a hypercompact stellar system, where its home was suddenly ripped away from its galaxy. That planet would now be traveling through the vast emptiness of intergalactic space, with no connection to any larger structure. What would happen to it? Would life survive? If a planet had the right conditions, perhaps a thick atmosphere or subsurface oceans, it might continue sustaining life even as it drifted into the darkness. In this case, hypercompact stellar systems might not just be cosmic relics. They could be carrying potential life forms across the universe. This brings us to another bizarre question. Could there be civilizations living within these systems, completely cut off from the rest of the universe? If an advanced civilization emerged on a planet within a hypercompact stellar system before it was ejected, they would have no knowledge of their origin galaxy. They would look up at the sky and see only distant galaxies, with no neighboring stars. Their entire concept of the universe would be completely different from ours. And if they had the ability to develop space travel, they would find themselves in an impossible situation. Unlike us, who can send probes and telescopes to study nearby stars, they would have nowhere to go. Their closest stellar neighbor might be millions of light years away. Would they even develop an understanding of galaxies? Would they theorize that they were the only civilization in existence, trapped in a cosmic void? Or could they be searching for others, sending signals into the darkness, hoping for a reply that will never come? Another layer to this mystery is how hypercompact stellar systems interact with dark matter. Galaxies are surrounded by vast halos of dark matter, which exert gravitational forces on everything within them. If hypercompact stellar systems move through these halos, could they act as probes, revealing the presence of this invisible substance? If dark matter interacts with ordinary matter in ways we don't yet understand, then these fast-moving systems might experience strange gravitational effects. They could be subtly pulled or slowed down in ways that don't match our expectations. If we could track their movements with extreme precision, we might be able to use them to map out the dark matter distribution in intergalactic space, potentially solving one of the greatest mysteries in physics. And then there's the question of black holes. If some of these systems contain intermediate mass black holes, left over from the galaxy they were torn from, then what happens when they collide with other objects? If a hypercompact stellar system containing a black hole were to pass close to a rogue planet, it might capture it, pulling it into orbit. Over time, this could lead to some of the most extreme celestial dynamics imaginable. Planets being flung around by black holes in a system that itself is hurtling through intergalactic space at thousands of kilometers per second. Could such interactions create new types of cosmic structures that we've never even considered? Could hypercompact stellar systems eventually merge with other rogue objects, forming entirely new celestial bodies in the void? And what about their long-term future? If they don't collide with another galaxy or get torn apart by internal gravitational interactions, how long can they last? Some astronomers believe that the most ancient stars in the universe are still shining today, over 13 billion years after they formed. If hypercompact stellar systems are made up of such stars, they could continue to exist for billions, perhaps even trillions, of years into the future. That means that long after our own galaxy has changed beyond recognition, long after the Milky Way has merged with Andromeda, long after the Sun has burned out and Earth has become uninhabitable, some of these stellar systems might still be out there, silently drifting through space. What will they see? Will they witness the end of the universe? As they move through the cosmos, will they pass by other civilizations, completely unaware of one another? Or will they remain alone, lost in the void, forever disconnected from everything else? Hypercompact stellar systems are more than just oddities. They are reminders of how chaotic, violent, and unpredictable the universe truly is. They challenge our understanding of gravity, galaxy formation, and even the nature of cosmic survival. They raise questions about dark matter, black holes, and the fate of stars that exist outside of galaxies. And they force us to rethink what it means to be part of a cosmic structure. Because our own galaxy is just one of billions. And if entire clusters of stars can be ripped away from their homes and sent hurtling through space, then nothing in the universe is truly permanent. Not even the galaxies themselves. The story of hypercompact stellar systems is still being written. With each new discovery, we uncover more about their origins, their nature, and their ultimate fate. But one thing is clear, they are among the strangest and most mysterious objects in the cosmos. And if we continue to study them, we may unlock secrets that go far beyond our current understanding, secrets that could change everything we know about the universe, and perhaps even reveal something unexpected about our own place within it. Hypercompact stellar systems are like ghosts of the cosmos, remnants of something that once was, now drifting through the void, carrying untold secrets of their violent past. Their very existence forces us to confront one of the most dramatic and chaotic forces in the universe: gravitational interactions between supermassive black holes. The most widely accepted theory behind these mysterious systems is that they are the leftover cores of galaxies that were ripped apart when their central black hole was ejected. But let's take a step back and break this down. How does something as massive as a supermassive black hole, millions or even billions of times the mass of the Sun, get thrown out of its own galaxy? It all comes down to one of the most powerful but least understood forces in the universe: gravitational recall. When two supermassive black holes merge, they don't just calmly fuse together. Instead, they release an enormous burst of gravitational waves, ripples in spacetime that carry away energy and momentum. This can cause the newly merged black hole to experience a kick, propelling it away at incredible speeds. In some cases, the recoil is so strong that the black hole is completely ejected from its home galaxy, leaving behind the stars that once surrounded it. What's left behind is a hypercompact stellar system, a tiny but incredibly dense cluster of stars that used to form the central bulge of a galaxy. But now, instead of being anchored to a massive galactic structure, it's on its own, racing through intergalactic space at thousands of kilometers per second. This raises an eerie thought. If hypercompact stellar systems are the remnants of galaxies that lost their black holes, how many galaxies out there have suffered a similar fate? Could there be entire galaxies that once thrived, only to be torn apart, leaving nothing but scattered remnants drifting endlessly? Even more unsettling is the idea that some of these systems might still contain an intermediate mass black hole at their center. These black holes, with masses ranging from hundreds to hundreds of thousands of times the Sun's mass, are among the most elusive objects in the universe. If some hypercompact stellar systems still harbor one, it could be slowly feeding on surrounding stars, gradually growing more massive over time. This raises another mystery. What happens if one of these systems collides with another galaxy? If a hypercompact stellar system containing an intermediate mass black hole were to fall into a larger galactic structure, would it reignite star formation? Would it disrupt the delicate balance of its new home? Or would it simply be absorbed, disappearing into the larger galaxy without a trace? The truth is, we don't know. But what we do know is that these objects are moving. Some of them are moving fast enough that they may never be bound to another galaxy again. Instead, they will spend eternity wandering through the dark space between galaxies, unseen and untouched. But what if they aren't alone? Hypercompact stellar systems could be among the most isolated objects in the universe, but they might not be the only ones out there. There could be thousands, maybe even millions, of these rogue clusters, all formed through similar violent events. Some may be closer to us than we realize, hidden within the cosmic web of dark matter and intergalactic dust. And this leads to an even bigger question: could some of them be carrying planets? If a hypercompact stellar system is the remnant of a galaxy core, it's not impossible that some of its stars once hosted planetary systems. Imagine a planet orbiting a star in one of these systems, blissfully unaware that its entire home galaxy was ripped apart millions or even billions of years ago. That planet, if it was fortunate enough to have the right conditions, could still be capable of sustaining life. But life in a hypercompact stellar system would be unlike anything we can imagine. The sky would be a strange sight. There would be no spiral arms, no galactic disk, no nearby stellar neighborhoods. The only visible light would come from the cluster of stars within the system itself, and beyond that, an overwhelming emptiness. For any civilization that evolved on such a planet, their understanding of the universe would be completely different from ours. They would have no concept of a home galaxy because they wouldn't have one. Their entire cosmic history would be a mystery. Would they ever realize that they were the survivors of a cosmic catastrophe? Or would they simply accept their lonely existence as the only reality they have ever known? This raises another haunting question: what if they have been trying to communicate? A civilization in a hypercompact stellar system might have developed radio technology, just like we have. They might have been sending signals for thousands of years, reaching out into the void, searching for others like them. But with no galactic backdrop to reflect their signals, no nearby civilizations to respond, they would never get a reply. Could it be that we have already detected their signals, but dismissed them as random cosmic noise? If a civilization trapped in such isolation were broadcasting, their signals might be weak, distorted, or completely different from anything we expect. And given how little we know about hypercompact stellar systems, we might not even be looking in the right places. But there's one final, terrifying possibility. What if some of these systems still contain their original supermassive black hole? Most theories suggest that hypercompact stellar systems are formed when the black hole is ejected, leaving only the stars behind. But what if, in some cases, the black hole remains? This would mean that deep within these tiny, fast-moving clusters, a hidden monster lurks, an ancient supermassive black hole, carrying the scars of its violent past. If such objects exist, they would be among the most dangerous things in the universe. A rogue supermassive black hole, surrounded by a dense cluster of stars, moving at thousands of kilometers per second through the cosmos. Unlike a normal galaxy, which remains relatively stationary, these black holes would be completely unpredictable, capable of passing through anything in their path. And if one were headed in our direction, we might not even see it coming. Hypercompact stellar systems remain one of the greatest unsolved mysteries in astrophysics. They defy our understanding of galaxy formation, gravitational dynamics, and even the limits of what we consider possible in the universe. They are relics of destruction, yet they endure, carrying the history of their lost galaxies with them. What other secrets do they hold? Could they teach us more about the chaotic nature of black hole mergers? Could they be used to detect dark matter? Could they contain hidden civilizations, cut off from the rest of the universe? One thing is certain, they are out there, moving through the vast darkness, silent witnesses to some of the most extreme events in cosmic history. And as our understanding of the universe grows, so too does the realization that we have barely scratched the surface of what these objects truly are. The more we uncover about hypercompact stellar systems, the more questions emerge. These ghostly remnants of galactic cores defy expectations, existing in a state that astronomers never predicted. But while we have theories about their origins, we are still in the early stages of understanding what they really are. One of the biggest challenges in studying these objects is their sheer isolation. Most galaxies are easy to spot because of their immense size and brightness, but hypercompact stellar systems are different. They are small, faint, and moving incredibly fast. Their high velocities mean they can quickly drift beyond the range of our telescopes, vanishing into the depths of intergalactic space. But what if some of them are closer than we think? The Milky Way has experienced multiple galaxy mergers in the past, and there is evidence that it has interacted with other galactic cores. If hypercompact stellar systems form when supermassive black holes are ejected, then it's possible that some of these systems could be lingering near our own galaxy, having been stripped from ancient dwarf galaxies long ago. Astronomers have found evidence of stars moving at extremely high velocities, some even exceeding the escape velocity of the Milky Way. These hypervelocity stars could be a clue that hypercompact stellar systems exist nearby. If we could identify one of these systems within a few million light-years of our own galaxy, it would provide an unprecedented opportunity to study them up close. But there's another aspect of these systems that makes them even more bizarre: their potential connection to dark matter. Dark matter is one of the greatest mysteries in astrophysics. We know it exists because of its gravitational effects on galaxies, but we have never directly detected it. Some researchers have suggested that hypercompact stellar systems could be key to unlocking the secrets of dark matter. The reasoning is simple: when a galaxy loses its black hole, it also loses the gravitational anchor that holds it together. Normally, we would expect the remaining stars to drift apart over time. But hypercompact stellar systems remain tightly packed, suggesting that something else is holding them together. One possibility is that these systems are embedded in dense halos of dark matter. If true, it would mean that even though their original galaxies were destroyed, the invisible dark matter structures that surrounded them are still intact. This could provide a new way to study dark matter, allowing scientists to probe its properties in ways that were previously impossible. But if hypercompact stellar systems are surrounded by dark matter, it raises another unsettling possibility. Could they act as cosmic traps? If these systems are moving at high speeds through intergalactic space, they could be sweeping up stray stars, gas, and even planets in their wake. A hypercompact stellar system passing through a dense region of space could capture objects in its gravitational field, adding them to its collection of ancient stars. Imagine a planet that formed billions of years ago in a completely different galaxy. Over time, it was pulled away from its home and became a rogue planet, drifting through space for millions of years. Then, by pure chance, it passed near a hypercompact stellar system and was captured by its gravity. Now, this lonely planet orbits within a cluster of ancient stars, completely unaware of its own history. Any life that might exist there would have no memory of its original galaxy. It would simply accept its new home as the only reality it has ever known. This brings us to one of the most unsettling questions of all. Could Earth itself be part of a hypercompact stellar system? At first, this idea seems ridiculous. The Sun is part of a relatively normal spiral galaxy, and there is no evidence to suggest that we were ever part of another system. But if hypercompact stellar systems can capture stars and planets, then it's theoretically possible that our solar system was once caught by such a system in the distant past. If this were true, it would mean that our understanding of Earth's cosmic history is completely wrong. Our planet might not have originally formed in the Milky Way at all. Instead, we could be a stolen world, unknowingly carried along by a relic of a long-lost galaxy. Of course, this is purely speculation. But it highlights the fact that we still don't fully understand hypercompact stellar systems. These objects exist at the very edge of our knowledge, defying our expectations at every turn. There is another question that haunts astronomers. What happens to these systems over time? If hypercompact stellar systems were formed billions of years ago, many of them should still exist today. But if they are moving at such high speeds, then where do they eventually end up? One possibility is that they will continue moving forever, never slowing down, never stopping. If that's the case, then these systems could be among the most isolated objects in the entire universe. But there is another possibility. What if some of them eventually slow down and merge with new galaxies? Galaxies are constantly interacting with one another, and some of them have massive halos of dark matter that extend for hundreds of thousands of light years. If a hypercompact stellar system were to pass through one of these halos, it might be slowed down by the gravitational effects of dark matter. Over time, it could be captured by the new galaxy, becoming part of its core. If this has happened in the past, then it means some galaxies today could be harboring hypercompact stellar systems without even realizing it. They could be hidden within galactic bulges, indistinguishable from the surrounding stars, waiting to be discovered. But there is one final possibility, one that is even more unsettling. What if some hypercompact stellar systems are not just remnants of destroyed galaxies, but the precursors to something even more extreme? Some astronomers have speculated that these systems could be the early stages of new quasars, active galactic nuclei that will eventually reignite and grow into full-fledged galaxies once again. If this is true, then hypercompact stellar systems are not just remnants of the past, they are the seeds of the future. Given enough time, they could accumulate new material, reignite their central black holes, and become powerful quasars capable of outshining entire galaxies. If this is happening right now, it would mean that the universe is constantly recycling itself. Galaxies are born, destroyed, and reborn in an endless cycle, with hypercompact stellar systems acting as the hidden intermediaries between these cosmic transformations. Hypercompact stellar systems remain one of the most enigmatic discoveries in modern astronomy. They challenge our understanding of galaxy formation, black hole dynamics, and even the fundamental nature of the universe itself. As our telescopes become more advanced, we will undoubtedly discover more of these objects. And with each new discovery, we will come closer to unraveling the full story of how they formed, what they are made of, and what their ultimate fate will be. But for now, they remain cosmic mysteries, silent wanderers in the vastness of space, carrying the secrets of the universe with them. Hypercompact stellar systems are more than just relics of the past. They are living proof that the universe is still evolving in ways we don't fully understand. These mysterious clusters, ejected from their home galaxies, defy our expectations of how celestial bodies behave. They move at speeds so high that they may never stop, destined to roam intergalactic space for eternity. But what if they are more than just wanderers? What if they are carrying the remnants of ancient civilizations, or even the seeds of new ones? Consider this. If a hypercompact stellar system was once the dense core of a galaxy, then any planets that were originally in orbit around its central black hole may still exist. The stars within these systems are packed tightly together, meaning that planetary systems could be subjected to extreme gravitational forces. If intelligent life had once evolved in one of these lost galaxies, what would have happened to it after the black hole was ejected? Would an advanced civilization have been able to predict the impending chaos, finding a way to escape before being flung into deep space? Or could they have adapted, developing technologies that allowed them to survive in the harsh conditions of intergalactic exile? If they endured, their home would be the ultimate isolated civilization, completely cut off from the rest of the universe, drifting in the cosmic void with no way to return. This raises another question. Could hypercompact stellar systems be the best places to search for signs of extraterrestrial intelligence? Most SETI, search for extraterrestrial intelligence, efforts focus on stars within stable galaxies, assuming that life will emerge in environments similar to our own. But if hypercompact stellar systems contain planets, and if those planets have existed for billions of years, then life may have evolved under conditions we never considered. Imagine an alien civilization that has lived its entire existence inside a hypercompact stellar system, never knowing anything beyond its small cluster of stars. To them, the universe would be a dark, empty place. The sky wouldn't be filled with the glow of a sprawling galaxy, but rather the blackness of intergalactic space, punctuated only by a handful of distant stars. Their understanding of reality would be completely different from our own. They might not even realize that galaxies exist at all, believing instead that their small system is all there is. If they developed advanced technology, they would face unique challenges. Without access to a full galaxy's worth of resources, how would they expand? Would they attempt to harness energy from their central black hole, or would they seek out other hypercompact stellar systems in the hope of finding more? And then there's an even stranger possibility. What if some of these systems have already made contact with one another? Hypercompact stellar systems may be rare, but they are not unique. If a civilization emerged in one of these systems and had billions of years to develop, it might have found ways to communicate across intergalactic distances. While we search for radio signals from planets in our own galaxy, what if the real conversations are happening between lost stellar systems, exchanging information across the void in ways we can't yet detect? This would mean that some of the oldest civilizations in the universe aren't in galaxies at all. They're in exile, drifting in the darkness between them. If they have survived for this long, their technology might be so advanced that they don't even need a home galaxy anymore. They could be completely self-sufficient, sustaining themselves using the energy of their black hole and the few stars around it. And what if they are watching us? If an intelligent civilization has lived in a hypercompact stellar system for billions of years, it would have had plenty of time to explore and study the universe. They may have sent probes to nearby galaxies, observing how other civilizations rise and fall. From their perspective, a massive galaxy like the Milky Way would seem chaotic and unstable, a place filled with constant collisions, supernova explosions, and unpredictable cosmic events. Would they ever attempt to make contact? Or would they see us as too primitive to understand them? The biggest challenge we face in finding these civilizations is their sheer distance. If hypercompact stellar systems are truly moving at high velocities through intergalactic space, then even if we detected one, reaching it would be nearly impossible. They could be millions of light years away, and by the time we figured out how to travel that far, they might have moved even farther. But what if one of these systems is headed toward us? If a hypercompact stellar system were on a trajectory toward the Milky Way, we might not even realize it until it was close. These objects are small and faint, difficult to detect unless we know exactly where to look. If one were approaching, it could take thousands or even millions of years to arrive, but once it entered our galaxy, it would be an event unlike anything in history. Its central black hole would disrupt the surrounding space, altering the orbits of nearby stars and potentially triggering new star formation. If it carried planets with it, those worlds would suddenly find themselves in an entirely new environment, exposed to radiation and gravitational forces they had never encountered before. And if there was life in that system, it would finally have a chance to interact with a new civilization, us. Of course, all of this is speculation. But it highlights just how much we don't know about hypercompact stellar systems. They challenge our understanding of black holes, galaxy formation, and even the fundamental nature of life itself. As we continue searching for them, we may find answers to some of the biggest questions in astrophysics. Or we may discover that reality is even stranger than we ever imagined. The universe is vast, and hypercompact stellar systems are proof that not everything follows the rules we expect. These rogue clusters of stars are out there, moving silently through the cosmos, carrying with them the secrets of the galaxies they once belonged to. And somewhere in the darkness, they are still waiting to be found. Hypercompact stellar systems are a reminder that the universe is not a static, predictable place. Every star, every galaxy, and even the fundamental forces that govern the cosmos are in constant motion, shaping and reshaping reality in ways we are only beginning to understand. The very existence of these rogue stellar systems suggests that entire galaxies may have been torn apart, their cores hurled into the void, leaving behind remnants that continue to drift through intergalactic space. But how many of these lost systems are out there? The truth is, we don't know. Hypercompact stellar systems are incredibly difficult to detect because they are so small and faint. Unlike massive galaxies that emit vast amounts of light, these compact clusters of stars may be barely visible against the blackness of space. If they are truly traveling at relativistic speeds, meaning a significant fraction of the speed of light, then they would be even harder to spot, as their motion could cause relativistic effects like redshift, stretching their light into wavelengths that are nearly undetectable. But there is another problem: these systems are likely ancient. If they were once the central regions of galaxies that merged and were ejected billions of years ago, then they could predate even some of the oldest known galaxies in the universe. This means that their stars may have burned out, leaving behind only black holes, neutron stars, and white dwarfs, objects that don't emit much visible light. Some hypercompact stellar systems may be nothing more than clusters of dead stars, drifting unseen through the darkness, waiting for us to find them. If we were able to detect these systems more reliably, what would we learn from them? Could they hold the key to understanding how supermassive black holes form? If every hypercompact stellar system contains a black hole at its center, then these objects might serve as natural laboratories for studying the physics of black hole interactions in extreme environments. The intense gravitational forces within these systems could allow us to observe phenomena like gravitational waves, time dilation, and even the warping of spacetime itself. And what if some of these black holes contain information from their original galaxies? Black holes are often thought of as cosmic vacuum cleaners, pulling in everything around them and never letting it escape. But some theories suggest that black holes might not just consume information, they could also store it in ways we don't yet understand. If a hypercompact stellar system was once the core of a galaxy, then the black hole at its center might still hold the gravitational imprint of the stars, planets, and even civilizations that once surrounded it. Could we extract that information? Some physicists believe that black holes might encode information on their event horizons in a way that could be recovered. If this is true, then studying a hypercompact stellar system could be like opening a cosmic time capsule, revealing details about the galaxy it once belonged to. This could allow us to reconstruct the history of lost galaxies, understanding not just how they were destroyed, but also what kinds of structures and life forms may have existed within them. And then there's an even stranger possibility. What if hypercompact stellar systems are more common than we think? If galactic mergers and black hole ejections are relatively frequent events, then the universe could be filled with these rogue systems, moving through intergalactic space like cosmic nomads. Some may be traveling alone, while others could be forming strange, loose collections of stars and black holes, creating entirely new types of celestial structures that we have yet to identify. Could these systems eventually merge with other galaxies? If a hypercompact stellar system were to enter a new galaxy, it would bring with it a completely different history, possibly even a different chemistry, if it came from an early universe environment with different conditions. This could introduce new elements, new types of stars, and even new possibilities for planet formation. What if some of the stars in our own galaxy originally came from a hypercompact stellar system? Astronomers have already found stars in the Milky Way that seem to have come from outside our galaxy, possibly ejected from smaller galaxies that merged with our own. If hypercompact stellar systems have been moving through intergalactic space for billions of years, then it's possible that some of them have already passed through larger galaxies, leaving behind a trail of stars as they moved on. This would mean that our own sky contains remnants of ancient, lost galaxies, stars that were once part of a thriving system but are now scattered across the cosmos. And what if our galaxy is creating new hypercompact stellar systems right now? Galaxies are constantly interacting with one another, and our own Milky Way is no exception. It is currently on a collision course with the Andromeda Galaxy, a massive spiral galaxy that will one day merge with our own, reshaping the structure of both. When this happens, it's possible that new hypercompact stellar systems will be formed as black holes interact, ejecting entire clusters of stars into deep space. Could one of those systems contain part of our own solar system? It may sound impossible, but if our galaxy's central black hole were to merge with another, the resulting chaos could send stars flying in all directions. If our Sun were somehow caught in one of these gravitational interactions, it could theoretically be flung from the galaxy, taking the entire solar system with it. In this scenario, Earth would become part of a hypercompact stellar system, drifting alone through intergalactic space with no way to return. Would life survive? The conditions in a hypercompact stellar system are extreme, but if planets can remain in stable orbits around their stars, then life might still persist. However, without the protection of a galaxy, such a system would be exposed to higher levels of cosmic radiation, interstellar debris, and other hazards. Advanced civilizations, if they existed in such a system, would need to develop ways to shield themselves from these dangers, possibly constructing artificial habitats or even moving their entire civilization underground. And if they survived for billions of years, would they ever try to find their way back? If a hypercompact stellar system was ejected from a galaxy long ago, its inhabitants, if they existed, might have passed down stories of their lost home, searching for a way to return. But by the time they developed the technology to travel back, their original galaxy might have changed beyond recognition. The structures they once knew would be gone, the stars they remembered would have burned out, and the civilizations they once coexisted with would have either evolved into something unrecognizable or disappeared entirely. Would they still feel the need to return? Or would they accept that their place in the universe had changed forever? Hypercompact stellar systems challenge everything we think we know about galaxies, black holes, and even the nature of cosmic evolution. They force us to reconsider our assumptions about where stars belong, how galaxies form, and what happens when the universe's most powerful forces collide. As our technology improves, we may begin to detect more of these rogue systems, uncovering the stories of the galaxies they once called home. And in the process, we may come to realize that the universe is far more dynamic and far more mysterious than we ever imagined. Hypercompact stellar systems may hold the key to understanding one of the greatest cosmic mysteries, the fate of galaxies in the distant future. If these rogue stellar clusters are the remnants of galactic collisions, then they offer a glimpse into the long-term evolution of the universe. Will galaxies continue to merge and grow, or will they be torn apart by violent interactions, leaving only isolated pockets of stars drifting through the void? Some models of cosmic evolution suggest that as the universe expands, galaxies will become increasingly isolated from one another. Dark energy is accelerating this expansion, stretching the fabric of space itself and pushing galaxies apart at an ever-increasing rate. But within galaxies, gravity is still the dominant force, pulling stars toward their centers, where supermassive black holes lurk. If galaxies continue to merge over billions of years, forming larger and larger structures, then hypercompact stellar systems may become more common as ejected remnants of these mergers. Could we one day see entire civilizations living in hypercompact stellar systems? If these systems contain stable planets, and if intelligent life arises on one of them, it would face a very different reality than we do. Instead of living in a vast galaxy filled with billions of stars, they would see only a small cluster of suns surrounded by the emptiness of intergalactic space. They would have no nearby galaxies to study, no cosmic neighbors to detect with telescopes, just an endless void stretching in all directions. Would such a civilization even know that other galaxies exist? If their history began in a hypercompact stellar system, they might assume that their small cluster of stars was the entire universe. Without a bright galactic core or the glow of distant nebulae, their night sky would be almost completely dark. Their understanding of the cosmos would be shaped entirely by the handful of stars in their system, and unless they developed extremely powerful telescopes, they might never realize that other galaxies exist at all. And if they did discover the existence of galaxies, how would they react? Imagine the shock of learning that your entire civilization is nothing more than a tiny fragment of a much larger structure, one that was violently torn apart long before your ancestors were even born. If they were able to develop space travel, they might spend generations trying to reach the nearest galaxy, hoping to find traces of the home they never knew. But by then, the universe would have changed beyond recognition. In the far future, galaxies may become increasingly isolated, making intergalactic travel even more difficult. If a civilization in a hypercompact stellar system attempted to reach a galaxy millions of light years away, they might arrive only to find that it had long since faded into darkness, its stars burned out, its planets frozen, and its black holes slowly evaporating. Would they still search for a home that no longer exists? Or would they accept that their place in the universe is forever adrift? Hypercompact stellar systems may not just be relics of the past, they could be the future of the universe itself. As galaxies continue to collide and supermassive black holes interact, more of these rogue systems may be created, carrying stars and planets away from their original galaxies and sending them on journeys that could last for eternity. And if our own galaxy eventually merges with Andromeda, who's to say that our own solar system won't become part of one? If the Milky Way and Andromeda collide, their central black holes will likely interact in a violent dance, distorting space-time itself. Some stars may be swallowed, while others may be hurled outward at incredible speeds. If our Sun were caught in one of these gravitational interactions, it could be ejected from the newly formed galaxy, sending Earth and the rest of the solar system into intergalactic space. If that happens, humanity would have no way to return. Our view of the night sky would change completely. No more galactic arms, no more bright nebulae, just an endless, starless abyss. Over time, the Sun would continue to burn, but without the protection of a galaxy's gravitational field, our solar system would be more vulnerable to rogue objects and cosmic radiation. Would humanity survive? If we had already become an interstellar civilization, spreading across multiple planets and artificial habitats, we might endure the transition. But if we were still confined to Earth, our chances would be much lower. The shift in our cosmic environment could introduce new risks, from increased asteroid impacts to higher radiation exposure. And if we did survive, would we try to find our way back? If we had the technology to navigate the vast emptiness of intergalactic space, we might attempt to return to the remnants of the Milky Way. But by then, it might be unrecognizable. The structures we once knew could be gone, the familiar constellations rearranged, and the civilizations we once coexisted with either extinct or transformed into something beyond our comprehension. Would we still see the Milky Way as our home? Or would we accept that our place in the universe had changed forever? Hypercompact stellar systems are a testament to the unpredictable nature of the cosmos. They remind us that nothing is permanent, not even galaxies. They force us to confront the reality that entire star systems can be uprooted, thrown into the void, and left to drift indefinitely. And yet, despite their isolation, they may still contain the echoes of the galaxies they once belonged to. Their stars, their black holes, and even their planets may hold clues about the cosmic events that shaped them. If we can find more of these systems, study them, and understand their origins, we may uncover secrets about the past, and perhaps even glimpses of the future. Because the universe is always in motion. Galaxies collide, black holes consume, and stars are flung into the unknown. Some are swallowed by the darkness, while others continue on, carrying the memories of lost worlds. And somewhere out there, beyond the reach of our telescopes, another hypercompact stellar system may be moving through intergalactic space right now, waiting for us to find it. If we ever do find a hypercompact stellar system up close, what would we actually see? Would it be a cluster of stars packed tightly together, glowing intensely in the void? Or would it be a scattered collection of dim suns, barely visible against the backdrop of space? The answer depends on the history of each individual system. Some hypercompact stellar systems may retain their original structure, with stars still orbiting their central black hole in a dense, chaotic swarm. Others may have stretched out over time, their stars drifting apart as they travel through intergalactic space. If planets exist within these systems, they may experience wildly different conditions depending on their position. Some planets may orbit close to their host stars, receiving a steady supply of warmth and light. But others may be stranded between stars, floating in the darkness as rogue planets. These rogue worlds would be some of the loneliest objects in the universe, cut off from the warmth of a sun, surrounded by the remains of a shattered galaxy, and drifting endlessly through the abyss. And what if one of these rogue planets harbored life? Could an advanced civilization survive in such extreme conditions? It sounds impossible, but under the right circumstances, life might still find a way. If a rogue planet has a thick atmosphere or a subsurface ocean heated by geothermal energy, it could sustain organisms even without a sun. In fact, some scientists believe that life on Earth could potentially endure even if our planet were ejected from the solar system. Deep-sea hydrothermal vents and underground microbial ecosystems could continue to thrive, insulated from the cold of space. If an intelligent species evolved on such a world, they would face unique challenges. They would have no sun to guide their sense of time, no seasons to mark the passage of years. Instead, their entire existence would depend on the internal heat of their planet, and any attempts at astronomy would reveal only a starless sky. How would they develop science without visible stars? Would they ever even imagine the existence of a larger universe? Or would they believe that their dark, frozen world was all there was? If we ever encounter a civilization from a hypercompact stellar system, they might see us as impossibly lucky, living under the warmth of a star, surrounded by billions of other suns, with entire galaxies within reach of our telescopes. To them, our night sky would be overwhelming, filled with lights they could never have imagined. And yet, they might have knowledge we don't. If they have survived in extreme isolation, they must have mastered energy production, resource management, and long-term survival in ways we haven't. They may have found solutions to problems we still struggle with: overpopulation, limited energy, environmental collapse. They may have no choice but to be a truly sustainable civilization, making use of every possible resource to endure in their cold, lightless world. Could we learn from them? Perhaps to them, our existence seems fragile. We are bound to our sun, dependent on a single star that will eventually die. They, on the other hand, have already adapted to life without a sun. While we look to the future with uncertainty, wondering how we will survive when our star ages, they have already faced that reality and overcome it. But despite all these possibilities, we are still in the early stages of understanding hypercompact stellar systems. We have only identified a few potential candidates, and their true nature remains uncertain. They could be much more common than we realize, hidden in the depths of intergalactic space, waiting to be discovered. So how do we find more of them? Detecting hypercompact stellar systems is a challenge because they lack the large, bright signatures of full galaxies. They don't produce vast clouds of glowing gas, they don't have spiral arms stretching across the cosmos, and they don't emit strong radio signals like active galactic nuclei. Instead, they are small, faint, and isolated. One method scientists use to locate them is by looking for clusters of stars moving unusually fast. Since these systems originate from galaxies that have undergone collisions, their stars may retain high velocities even after being ejected. By analyzing the motion of star clusters, astronomers can identify candidates that don't fit within any known galaxy. Another way to find them is by detecting their central black holes. Even though these black holes are much smaller than the supermassive ones at the centers of galaxies, they can still produce detectable X-ray and radio emissions when they consume nearby material. If a hypercompact stellar system contains a central black hole, its occasional bursts of radiation may reveal its location. But the biggest challenge is simply the vastness of space. Intergalactic space is enormous, and even if hypercompact stellar systems exist in large numbers, they are spread out across distances that are nearly impossible to comprehend. Some may be millions of light years from the nearest galaxy, making them incredibly difficult to detect. We may have already seen some in astronomical surveys without realizing it, mistaking them for ordinary star clusters or distant background objects. This means that finding them will require new techniques, better telescopes, and a deeper understanding of how these systems evolve. It may take years, even decades, before we have a complete picture of their role in the universe. And when we finally uncover the full story, what will it tell us? Will we discover that hypercompact stellar systems are rare cosmic accidents, formed only in the most extreme circumstances? Or will we learn that they are common, and that countless stars have been flung into intergalactic space over billions of years? If they turn out to be widespread, it could change our entire understanding of galactic evolution. It could mean that the process of galaxy formation is even more chaotic than we thought, with stars constantly being created, destroyed, and ejected in ways we never imagined. And if that's the case, then the universe is even more dynamic than we ever realized. Hypercompact stellar systems may not just be footnotes in the history of galaxies. They could be essential pieces of the cosmic puzzle, revealing hidden processes that have shaped the structure of the universe. They could show us that even in the cold, empty void between galaxies, there is still movement, still transformation, still the possibility of something new. And maybe, just maybe, they could one day be a home for us. If humanity ever ventures beyond the Milky Way, if we leave our home galaxy behind and travel into intergalactic space, we may find ourselves drawn to these systems. They may become waypoints on our journey, places where we can find resources, shelter, or even new homes. We may not be able to return to the Milky Way, but we could carry its memory with us. We could take the knowledge of where we came from and build something new in the depths of intergalactic space. And if we do, then hypercompact stellar systems won't just be relics of the past. They will be part of our future. Hypercompact stellar systems may seem like distant curiosities, but in reality, they could hold the key to understanding some of the most fundamental aspects of the universe. These systems are not just remnants of galactic collisions, they are living records of cosmic history, carrying with them the scars of their violent pasts. Each one is a snapshot of a moment when galaxies collided, when black holes merged, when stars were torn from their homes and flung into the abyss. If we could study these systems in greater detail, we might uncover new clues about the nature of gravity, the behavior of black holes, and even the large-scale structure of the cosmos. But doing so requires us to overcome some of the biggest challenges in astronomy. One of the main difficulties is their sheer distance. Because hypercompact stellar systems exist outside of galaxies, they can be incredibly far from any region of space we typically study. Most of the telescopes we use today are designed to observe galaxies, nebulae, and other large structures within the universe. But these systems are much smaller, much fainter, and much harder to detect against the backdrop of space. To truly find and analyze them, we need telescopes that can resolve incredibly fine details. The upcoming generation of space telescopes, like the James Webb Space Telescope and the next wave of ground-based observatories, may help us make progress. These instruments will allow us to look deeper into space than ever before, capturing high-resolution images of objects that were once invisible to us. Another approach is to look for the telltale signs of their motion. Since these systems originate from galaxies that have experienced high-energy events, they often retain high velocities. By tracking groups of stars that move faster than expected, astronomers can pinpoint potential hypercompact stellar systems. But what if there's another way to find them? What if we're already seeing them without realizing it? Some researchers believe that hypercompact stellar systems might be mistaken for other types of celestial objects. For example, certain star clusters that appear isolated in deep space could actually be the remnants of these systems. Similarly, some sources of unexplained X-ray or radio emissions might be the signatures of black holes at the heart of these systems. If that's the case, then we may already have data on them. We just need to recognize it. And if we do, it could change the way we think about the universe. Consider this: if hypercompact stellar systems are common, it means that the process of galaxy formation is far more chaotic than we ever realized. Instead of galaxies being stable, isolated structures, they would be constantly interacting, merging, and flinging stars into intergalactic space. This would suggest that the universe is a much more dynamic place than we thought. Instead of galaxies being separate entities, they would be engaged in an ongoing dance, exchanging stars, gas, and even black holes. It would mean that intergalactic space is not empty, but filled with remnants of past events, clusters of stars that drift between the great cosmic cities we call galaxies. And if hypercompact stellar systems are common, it raises another question. Could life exist in them? It seems unlikely at first. After all, these systems are created by violent processes: galaxies colliding, stars being torn apart, black holes consuming everything in their path. But if planets survive these events, and if they remain in stable orbits around their stars, then life might have a chance. Imagine a civilization that evolved on a planet in one of these systems. Unlike us, they would not have a galaxy to call home. They would have no spiral arms overhead, no glowing bands of stars stretching across their sky. Instead, their night sky would be almost entirely black, with only a handful of distant stars visible. To them, the concept of a galaxy might be unimaginable. They might believe that their small cluster of stars is all that exists. They would have no way of seeing the vast, interconnected web of galaxies that fills the universe. And if they develop the technology to explore space, they might eventually make a shocking discovery. They are alone in the void. No nearby galaxies. No bright nebulae. Just an endless emptiness stretching in every direction. How would they react to such knowledge? Would they see themselves as the last survivors of a cosmic disaster? Or would they believe that they were always meant to be alone, drifting forever in the darkness? These questions may sound like science fiction, but they are rooted in real astrophysics. If hypercompact stellar systems exist, then they are not just scientific curiosities. They are potential homes for planets, for life, for entire civilizations that could be cut off from the rest of the universe. And if we ever find evidence of such civilizations, it will force us to reconsider everything we thought we knew about life in the cosmos. We often assume that life must exist in galaxies, that planets need to be part of a stable star system within a galaxy to support complex organisms. But hypercompact stellar systems challenge that assumption. They show us that stars, planets, and even civilizations could exist outside the familiar boundaries of galaxies, drifting through the abyss in ways we never imagined. And if that's true, then our search for extraterrestrial life might be missing an entire category of potential civilizations. We focus on looking for life within galaxies because that's what we understand. But what if some of the most advanced civilizations in the universe are not bound to galaxies at all? What if they exist in the spaces between, thriving in isolated star clusters that were once part of galaxies but are now lost to the void? If we truly want to find intelligent life beyond Earth, we may need to rethink our search entirely. Instead of just looking at planets orbiting stars within galaxies, we may need to look in the places we least expect, deep within intergalactic space, where hypercompact stellar systems wander, carrying with them the last remnants of lost galaxies. And if we do find something, if we detect a signal, an artificial structure, or some undeniable sign of intelligent life, it will rewrite everything we know about our place in the universe. Because it will mean that even in the coldest, darkest reaches of space, life can still find a way. And if life can survive there, if it can endure in the most extreme conditions imaginable, then maybe the universe is far more alive than we ever dared to believe. If hypercompact stellar systems exist in large numbers throughout the universe, then our understanding of cosmic evolution needs to change. We typically think of galaxies as stable structures, but these systems suggest that galaxies are constantly shedding material, flinging stars, planets, and possibly entire civilizations into intergalactic space. This raises an unsettling question: how many stars have been lost to the void, never to return? The numbers might be larger than we ever imagined. Every time two galaxies collide, their gravitational forces tug at each other's stars, creating long tidal tails that stretch across space. Some stars are drawn into new orbits within the merged galaxy, but others are ejected entirely. Over billions of years, these interactions could create a vast population of rogue star clusters drifting through the darkness, completely disconnected from any galaxy. And yet, despite being untethered, these systems can survive. Gravity binds their stars together tightly enough that even without a galactic core to anchor them, they remain intact, glowing faintly in the endless night. But what happens to the black holes at their centers? A hypercompact stellar system is believed to be the remnant of a galaxy's core, meaning it could still contain a supermassive black hole. However, a black hole that loses its surrounding galaxy might behave very differently from those we typically study. One possibility is that the black hole retains a small accretion disk, slowly consuming whatever material remains from the original galaxy. If so, it might still emit powerful X-rays and radio waves, making it detectable even from millions of light-years away. Another possibility is that it goes completely dark. Without nearby stars feeding it, the black hole might become nearly invisible, a silent predator drifting through space. If such objects exist in large numbers, then the universe could be full of dark, black holes, massive, undetectable objects that have no clear source of emissions. But what if some of them are still active? What if, even in intergalactic space, these black holes continue to pull in matter, whether from wandering gas clouds, nearby stars, or even entire planets that stray too close? If that's the case, then hypercompact stellar systems could be home to some of the most extreme black hole activity in the universe. These systems would be like miniature galaxies, each with its own high-energy core, radiating massive amounts of energy despite their tiny size. And if they can produce such energy, then they might be detectable. Astronomers could search for isolated sources of X-rays or radio waves, looking for signatures that don't match known galaxies or quasars. By identifying these strange signals, we might finally be able to pinpoint the locations of hypercompact stellar systems scattered throughout the cosmos. But what if we've already found them? What if some of the unexplained X-ray sources we've detected in deep space aren't just random anomalies, but actual evidence of these systems? There are already plenty of mysterious cosmic signals that don't fit into our current understanding: unusual bursts of energy, unexplained flickering lights, and distant objects that appear far brighter than they should be. Some of these could be the remains of galaxies that were ripped apart billions of years ago, their cores still glowing as they wander the intergalactic void. And if that's true, then hypercompact stellar systems could be far more common than we think. We might have been looking at them this entire time without realizing what they were. If that's the case, then we need to rethink our approach to studying the universe. Instead of just focusing on the galaxies themselves, we need to pay attention to the spaces between them, the vast, empty voids that we've long assumed were desolate and uninteresting. Because if hypercompact stellar systems exist, then those voids might not be empty at all. They might be filled with remnants of galaxies that no longer exist, silent witnesses to cosmic destruction, carrying with them the last traces of civilizations that once thrived. And if we ever discover one of these civilizations, if we ever detect signs of life in a hypercompact stellar system, it will completely change our understanding of what's possible. It will prove that even in the loneliest, most extreme environments, life can endure. And if life can survive in the void between galaxies, then perhaps no part of the universe is truly lifeless. If life could persist within a hypercompact stellar system, it would challenge everything we assume about habitability. Traditionally, we look for planets orbiting stable stars within galaxies, protected by the collective gravity of billions of other stars. But what if life doesn't need that stability? What if it can thrive in the darkness, in a place where the only source of light is the faint glow of distant stars scattered across the cosmic abyss. Imagine a planet orbiting a star within a hypercompact stellar system, a world flung from its home galaxy, now drifting in intergalactic space. The sky above would be unlike anything we know. No Milky Way stretching across the heavens, no familiar constellations. Just the scattered lights of galaxies millions of light years away, each one a tiny, lonely beacon in an otherwise endless black sea. Could such a world support life? The immediate answer might seem like a resounding no. After all, galaxies provide an essential ingredient for life: raw materials. Interstellar clouds within galaxies contain the building blocks of planets, atmospheres, and even biological molecules. If a hypercompact stellar system exists outside of a galaxy, where does it get these materials? But here's the thing, just because a system is ejected from a galaxy doesn't mean it loses all of its resources. If a planet already had an atmosphere, an ocean, or even microbial life before it was flung into the void, that life might continue to persist in some form. The planet might still receive warmth from its parent star, and if it has a thick enough atmosphere or underground heat sources, it might retain enough energy to sustain some kind of biosphere. And what if these systems still pass through intergalactic gas clouds? The space between galaxies isn't completely empty. There are vast, diffuse clouds of gas stretching across the cosmos, remnants of ancient stellar explosions and galactic collisions. If a hypercompact stellar system drifts through one of these clouds, it could replenish its lost materials, gathering just enough to keep its stars burning and its planets intact. In that case, a planet within such a system wouldn't just be surviving, it might even be thriving. Now let's go deeper. If intelligent life evolved in a hypercompact stellar system, their entire understanding of the universe would be radically different from ours. Think about it. They wouldn't have a galaxy to observe. They wouldn't have the same clear view of star formation, nebulae, or galactic motion that we do. To them, the universe might appear as a mostly empty void with only the faintest specks of light in the distance. Would they even understand that galaxies exist? If they had no way to observe the large-scale structures of the universe, their entire concept of astronomy might be drastically different. They might think that the universe consists of only a few scattered stars, with no grand cosmic structures to unify them. And here's the most mind-bending part. What if they were the first to develop interstellar travel? If a civilization evolved in a hypercompact stellar system, it would have one major advantage: freedom. Most advanced civilizations would have to deal with the immense gravity of their home galaxies. Moving between stars within a galaxy is already a massive challenge, requiring immense amounts of energy to escape a galaxy's gravitational well. But in intergalactic space, there is no such barrier. A civilization living in the void would have an easier time reaching neighboring star systems, simply because there's no galactic gravity holding them back. They could travel between isolated hypercompact stellar systems with far less energy than it would take for us to travel between stars within the Milky Way. What if such a civilization has already spread across intergalactic space? What if they exist in the gaps between galaxies, traveling between rogue star systems, never needing to settle in one place for too long? That would mean we've been looking in the wrong places this entire time. We've been searching for extraterrestrial signals within galaxies, assuming that life must exist where stars are densely packed. But if an advanced civilization is already living in intergalactic space, they might not even need galaxies. They could be moving freely between isolated star systems, using energy sources we haven't even imagined. And here's a chilling thought: what if they already know about us? What if they've been watching? From their perspective, we would seem like a civilization trapped in a gravitational prison, unable to escape our galactic boundaries. To them, the Milky Way might look like a dangerous, chaotic place, full of colliding stars, black holes, and unpredictable events. They might see our reliance on galaxies as primitive, an unnecessary dependence on structures that are ultimately doomed to change or collapse. Would they ever try to contact us? Or would they simply remain in the void, unseen and unknown, moving between hypercompact stellar systems, far beyond our reach? And what if, one day, we develop the technology to escape our own galaxy? If we ever reach intergalactic space, will we find these civilizations waiting for us? Or will we discover that they've been avoiding us all along? If an intergalactic civilization exists, avoiding us might not be out of fear, but out of necessity. Think about it. Any species capable of thriving in the void between galaxies would have to be far beyond us technologically. They would have mastered energy sources we barely comprehend, developed spacecraft that can endure for millennia, and engineered entire ecosystems that don't rely on the warmth of a galaxy's core. They might see us as unstable, unpredictable, and perhaps even dangerous. After all, human history is filled with examples of one civilization encountering another, often with disastrous consequences. To a species that has survived for millions of years in the empty stretches of intergalactic space, why take the risk of interacting with a species still confined to its home galaxy? They might not be avoiding us out of fear of what we might do to them, but rather out of caution, because they've seen what civilizations do when they expand too fast, consume too many resources, or fail to control their own technology. But let's flip the scenario. What if they aren't avoiding us? What if they've already been here? A civilization accustomed to the darkness of intergalactic space wouldn't need planets to survive. They might prefer to live in massive space stations, artificial worlds of their own design. If that's the case, then their technology might not leave behind the same traces we expect when searching for alien life. We look for radio signals, Dyson spheres, or chemical signatures in exoplanet atmospheres. But what if their structures are designed to be undetectable? Think about this. If they have been traveling between hypercompact stellar systems for millions of years, they might have visited galaxies before. Maybe even ours. Could it be possible that some of the strange anomalies we observe, like unexplained bursts of energy, gravitational distortions, or oddly behaving stars, are evidence of their presence? Could they be watching, waiting to see if we will one day join them in the intergalactic void? Or could they already be here, hidden in places we never thought to look? If a hypercompact stellar system drifted close enough to our galaxy, it could be indistinguishable from an ordinary cluster of stars. But what if one of these systems has already been captured by the Milky Way's gravity? What if, somewhere in the outer halo of our galaxy, there's an ancient cluster of stars that doesn't belong, a system that was once part of another galaxy, now drifting at the edges of our own? Would we even notice? Astronomers are still mapping the outskirts of the Milky Way, discovering new structures and rogue star clusters. Some of these clusters move in ways that don't quite fit our models. Could some of them be remnants of hypercompact stellar systems, slowly integrating into our galaxy after eons in the void? And if so, what else might they be carrying with them? If life ever evolved in one of these lost systems, it might have spent millions or even billions of years adapting to intergalactic conditions. If such life existed, it would be utterly unlike anything we know, perhaps thriving in ways we can't yet comprehend. But what if we eventually make contact? What if, one day, we detect an object moving toward us from the vast emptiness between galaxies, not a meteor, not a comet, but something far stranger? What if it's a vessel? A ship, designed to survive for eons in intergalactic space, drifting slowly toward our galaxy? Would we recognize it for what it is? Would we be able to decipher its origins, or would we mistake it for just another celestial body, dismissing it as an anomaly? Or worse, what if we don't see it coming at all? What if, in the vastness of space, something is already watching us? Something from the darkness beyond our galaxy. Something that understands what we are, long before we ever understand what it is. And what if, when we finally reach out to the stars, we find that we are not the first to do so? What if we are not alone, not just in the galaxy, but in the endless, silent void beyond? If something, someone, is out there, watching us from the void beyond galaxies, what would they see? They would see a species still struggling to understand its place in the cosmos. A civilization bound to a single planet, slowly stretching its reach to the stars, yet still primitive compared to the vast timescales of the universe. They would see our attempts to explore space, our telescopes scanning the night sky, our robotic probes sent to the outer reaches of our solar system, our first small steps toward interstellar travel. They would know that we are curious, that we are reaching, that we are desperate to know if we are alone. And maybe they would be asking the same question. If a civilization has existed in intergalactic space for millions of years, they might not just be observing, they might be searching. Even if they are far more advanced than us, there's no guarantee that they have met anyone else. The universe is incomprehensibly vast, and intelligent life may be far rarer than we assume. If they, too, have been alone for eons, then perhaps they are just as eager to find others as we are. But here's where it gets interesting. If they have been looking, why haven't they revealed themselves? Maybe they have rules. A civilization that has survived for millions of years must have learned the dangers of interference. They would know that contact with a younger, less advanced species could have catastrophic consequences. What if their policy is to wait, to observe from a distance, to see whether we mature enough to reach out on our own? Or perhaps they have seen what happens when civilizations grow too quickly. What if they have watched other intelligent species rise and fall? Perhaps they have witnessed civilizations destroy themselves before ever reaching the stars. Maybe they've seen species that became too dependent on their home galaxies, consuming resources until they collapsed. If that's the case, they might see us as a test, a civilization at a crossroads, teetering between survival and self-destruction. Would they step in to help? Or would they simply wait, knowing that intervention might cause more harm than good? And here's a darker thought. What if they aren't benevolent at all? What if a civilization living in intergalactic space is not just surviving but thriving, expanding, conquering, consuming? If they have mastered the ability to live between galaxies, they would have no competition. They wouldn't have to share resources, negotiate with other species, or worry about territorial conflicts. They would be the rulers of the void, the ultimate survivors in the cold darkness of space. Would such a civilization welcome us? Or would they see us as a potential threat? If they know we exist, they would also know that we are still confined to our galaxy. We are limited by gravity, by technology, by our own biological constraints. But what happens when that changes? What happens when we develop the ability to leave our galaxy behind? The moment humanity discovers true intergalactic travel, we cease to be a species locked within a single star system. We become something far greater, something capable of spreading, expanding, and eventually competing with whoever else might be out there. Would an ancient, intergalactic civilization allow that? Or would they take steps to stop it before it happens? Perhaps this is why we haven't heard from them. Not because they aren't there. Not because they aren't looking. But because they are waiting. Waiting to see if we become something they must acknowledge. Or something they must eliminate. If an intergalactic civilization exists, waiting silently in the void between galaxies, the most unsettling question isn't whether they are out there, it's whether they have already decided our fate. Imagine a species that has lived for millions, perhaps even billions of years, without the constraints of planetary survival. They would have mastered energy in ways we can't comprehend, possibly drawing power directly from the quantum fluctuations of empty space or harnessing the energy of entire stars. They would have evolved past the need for planets, possibly even past the need for biological bodies. Instead, they might exist as post-organic entities, vast, artificial intelligences that no longer rely on flesh and blood, but instead live as digital minds scattered across vast, self-repairing megastructures, floating in the darkness between galaxies. To them, we might seem like nothing more than a brief flicker of intelligence in the cosmic timeline, something to be observed and then forgotten. But what if they don't forget? What if they are watching, not out of curiosity, but because they are waiting for something? The nature of hypercompact stellar systems is already strange enough, a collection of stars ejected from their parent galaxy, held together by gravity, as they drift endlessly through intergalactic space. But what if these systems are more than just random stellar remnants? What if they are the remnants of something else? A lost civilization, perhaps. A last refuge of a species that tried to escape some cosmic catastrophe. Or maybe they were created, deliberately engineered as way stations, outposts in the emptiness between galaxies, used by an ancient species that once traveled the void but has since vanished. If such a species ever existed, they would have left something behind. Relics, artifacts, structures that defy our understanding, things that might still be drifting out there, waiting to be found. But what if they aren't just waiting? What if they are still functional? If a civilization learned how to survive outside of galaxies, they would have to be experts in resource management. They wouldn't waste anything, not energy, not matter, not even information. They would build self-repairing structures, automated defenses, and possibly even artificial life forms designed to protect their legacy. What if, hidden within one of these hypercompact stellar systems, there is something still operational? Something ancient. Something built for a purpose we don't yet understand. A machine, perhaps, still waiting for the right conditions to activate. Or worse, something designed to wake up when it detects new, intelligent life. If that were the case, then any attempt to explore these systems could trigger events beyond our control. There is a possibility, however small, that humanity has already sent signals into the void that have been received by something we cannot even comprehend. We send radio waves into space, we scan the sky with powerful telescopes, we reach further with every new mission. But we do so with the assumption that space is empty, that if anyone is out there, they will be like us, biological, curious, and eager for contact. What if we are wrong? What if the beings capable of surviving in intergalactic space have evolved beyond emotion, beyond curiosity, beyond any concept we would recognize as life? They might not care about communication. They might not even care about us at all. They might see us as irrelevant, another short-lived experiment of nature that will inevitably destroy itself before ever becoming a real concern. But what if they do care? The most terrifying possibility isn't that we are alone in the universe. It's that we are not alone, and something out there already knows we exist. And if they know, the next question is simple: what will they do about it? There's a chance that they see us as potential allies, another species on the verge of intergalactic travel, ready to be welcomed into a network of civilizations that have long since left their home galaxies behind. But there's also the darker possibility that they see us as a threat, a species that, if left unchecked, could one day become dangerous. If they have been watching civilizations rise and fall for millions of years, they might have developed rules. Rules about which species are allowed to expand and which ones must be eliminated before they become a problem. It's even possible that the reason we don't see other advanced civilizations is because of them. What if the void between galaxies isn't empty because life never developed there, but because something ensures that no civilization ever expands beyond a certain point? What if every time a species reaches the threshold of intergalactic travel, they are erased? If such a force exists, it would be beyond anything we can resist. A civilization capable of surviving in deep space would have access to technologies we can't even imagine. They could manipulate gravity, create weapons that destroy entire solar systems, or even rewrite the very fabric of space-time to ensure that no new civilizations ever emerge. But there's one more possibility, one that is even more unsettling. What if we are not the first species to reach this stage? What if, long ago, other civilizations from the Milky Way tried to escape into intergalactic space, only to be stopped? What if the reason we see no signs of intergalactic civilizations is because every attempt to leave the galaxy has been met with total annihilation? If that's true, then our future is already decided. The moment we develop true intergalactic travel, we will be noticed. And then, we will find out what happens next. For now, we are still safe. We are still hidden, a young civilization confined to its home galaxy. But that won't last forever. One day, we will take that step. One day, we will send a ship beyond the borders of the Milky Way, into the vast, silent darkness beyond. And when we do, we might not like what we find waiting for us. If something is waiting for us in the void beyond galaxies, then every step we take toward intergalactic travel brings us closer to an encounter we may not be prepared for. Right now, humanity is in a strange position. We are just intelligent enough to ask these terrifying questions, yet still too primitive to answer them. We look out into space and wonder why we see no evidence of other civilizations. We theorize about the Great Filter, the possibility that something prevents life from reaching higher stages of advancement. But what if the filter isn't some unavoidable cosmic event? What if it's a decision? A choice made by something so old, so powerful, that it decides the fate of civilizations before they ever become intergalactic? Consider how young we are in cosmic terms. The universe is 13.8 billion years old, and our species has existed for a fraction of that time. We've only had advanced technology for a few centuries. We only started sending signals into space a few decades ago. If there are civilizations that have lived in intergalactic space for millions or billions of years, then to them, we are nothing more than an emerging intelligence, one that has not yet proven itself capable of surviving. But what if our survival depends on remaining unnoticed? Hypercompact stellar systems are some of the strangest objects in the universe, and we still don't fully understand them. They are clusters of stars that have been thrown out of their galaxies, exiled into the endless void between galactic structures. But why do they exist? How do they form? Some theories suggest they are created when a supermassive black hole disrupts a smaller galaxy, ejecting its core into intergalactic space. Others suggest that they might be remnants of galactic collisions, small groups of stars that were caught in gravitational chaos and thrown into the void. But here's a question no one wants to ask: what if they weren't ejected? What if they were placed there? If an advanced civilization wanted to hide, it wouldn't do so within a galaxy, surrounded by other stars and planets. It would go to the most isolated places in the universe, the regions where no natural signals could escape, where detection would be nearly impossible. Hypercompact stellar systems might be more than just wandering remnants of destroyed galaxies. They could be the remnants of civilizations that deliberately left their galaxies behind, seeking safety in the void. And if that's true, then what were they running from? There's another possibility, one even more unsettling. What if hypercompact stellar systems are not hiding places, but warnings? If a civilization was powerful enough to destroy entire star systems, it wouldn't leave behind obvious evidence of its actions. It wouldn't leave ruined planets or shattered megastructures. Instead, it might leave behind something that looks natural, something that future civilizations wouldn't think to question. A cluster of stars drifting in intergalactic space, seemingly formed by natural gravitational forces. But in reality, these systems might be the only evidence left of something far more terrifying, a force capable of erasing entire civilizations without a trace. We often assume that if a highly advanced civilization exists, it would be peaceful. We assume that intelligence leads to cooperation, that progress leads to morality. But that's a dangerous assumption. Nature doesn't favor kindness, it favors survival. If a civilization survived for millions of years, it wouldn't be because it was benevolent. It would be because it was ruthless. Because it knew how to eliminate threats before they became dangerous. And if such a civilization is out there, watching us from the darkness, then our rapid technological advancement might not be a sign of progress, it might be a death sentence. Think about what we have done in just the past century. We have begun experimenting with artificial intelligence, a technology that could surpass our own intelligence within our lifetimes. We are already looking at ways to manipulate the fabric of space-time, to create warp drives, to bend the laws of physics themselves. If an ancient civilization has been watching us, then they know exactly where this path leads. They have seen species like us before, species that rise too quickly, species that become too ambitious. And they know what must be done. But what if we are already too late? What if, the moment we started sending signals into space, the moment we began reaching beyond our solar system, something took notice? What if we have already been marked as a civilization that must be dealt with? We wouldn't know. We wouldn't see it coming. If they are truly intergalactic, if they have technology that defies our understanding, then their methods wouldn't be something we could resist. They wouldn't attack us with fleets of ships or massive weapons. They wouldn't invade our planet like in science fiction movies. Instead, they might use something far more precise, an engineered event, something that looks natural but isn't. An anomaly in the sun that causes it to eject a devastating solar flare. A subtle shift in Earth's orbit that leads to a catastrophic climate collapse. A biological event, a virus that seems to emerge naturally but is far too efficient to be coincidence. If an advanced civilization wanted to remove us, it wouldn't leave evidence. It wouldn't start a war. It would make sure that we simply disappeared, leaving nothing behind but a silent planet orbiting a dying star. But if this is true, then why hasn't it happened yet? If they have the ability to eliminate us, why haven't they done it already? The answer might be time. We assume that because we are accelerating technologically, that other civilizations must be watching us in real time. But what if they aren't? What if their observations are delayed by thousands, even millions of years? If they are monitoring civilizations across the universe, they might not be able to react instantly. They might have detected our early radio signals decades ago, and only now be deciding what to do about us. Or worse, they might have already sent something our way, and we just haven't seen it yet. A probe, perhaps. A self-replicating machine designed to reach us, to study us, to decide whether we are worth keeping alive. If such a probe exists, it wouldn't announce itself. It would watch. It would collect data. And when the time was right, it would make its decision. And that's the most terrifying thought of all, because if such a thing is already here, hidden in our solar system, then the decision may have already been made. If something is out there, watching, then every step we take into the unknown could be our last without us even realizing it. We have always assumed that our greatest threats would come from within: wars, climate change, artificial intelligence spiraling out of control. But what if our biggest mistake isn't anything we do here on Earth? What if our greatest mistake is simply being noticed? Hypercompact stellar systems are not supposed to exist in the way that they do. When we first discovered them, they seemed like anomalies, clusters of stars that had been flung into intergalactic space by the sheer gravitational chaos of colliding galaxies. But the more we study them, the stranger they become. Unlike normal galaxies, they lack the expected number of stars. Their composition is unusual, often appearing far too dense for their location. Some seem to have an energy output that doesn't quite match their visible mass, as if something unseen is influencing them. And the strangest part? They shouldn't be able to survive long-term in the void, yet they do. This raises a disturbing possibility. What if they are not just random clusters of stars, but something else entirely? Imagine a civilization that has lived for millions, perhaps billions of years. Such a civilization wouldn't just be advanced, it would be beyond our comprehension. It would have had time to master physics in ways we can't even imagine. It might have discovered methods to manipulate entire star systems, to bend space-time, to create structures so vast and powerful that they appear indistinguishable from natural formations. And if such a civilization wanted to leave no trace of itself, it wouldn't construct obvious megastructures. It wouldn't build massive Dyson spheres or artificial planets that could be detected. Instead, it would make something that blends in, something that looks like a natural formation but isn't. Hypercompact stellar systems might not be rogue clusters of stars at all. They could be artificial. But why would a civilization go to such lengths to disguise itself? The answer might be fear. We tend to assume that advanced civilizations are safe from threats, that intelligence guarantees survival. But what if the universe is far more hostile than we realize? What if the reason we don't see evidence of other civilizations isn't because they never existed, but because the ones that survived learned to hide? Think about what we do when we don't want to be found. We turn off the lights. We go quiet. We avoid drawing attention. If there is something in the universe that preys on civilizations, then any species that figures this out in time would do the same. They wouldn't broadcast signals. They wouldn't leave behind obvious structures. They wouldn't expand recklessly into space. Instead, they would erase all traces of themselves, pulling their entire civilization into deep intergalactic space where no one would think to look. They would disguise themselves as something unremarkable, just another cluster of stars, drifting alone in the void. But if this is true, then it raises an even more terrifying question. What are they hiding from? The idea that we might not be alone is terrifying enough. But the idea that the ones who are out there, the ones advanced enough to escape detection, are in hiding? That is something far worse. It suggests that the universe is not just indifferent to life, but actively hostile to it. It suggests that civilizations that expand too far, that make too much noise, that try to claim too much of the cosmos, are eliminated before they can pose a threat to something greater. And here we are sending signals, launching probes, expanding our reach further and further with each passing decade. We are doing exactly what a young civilization would do before it learns the truth. Before it learns why the night sky is so quiet. But maybe we won't have to wait long for an answer. Consider this. If there really is something out there eliminating civilizations before they reach a certain threshold, then whatever it is must have a system. A pattern. A way of determining when a species has become a threat. Maybe it waits until a civilization achieves interstellar travel. Maybe it waits until a species begins to develop artificial intelligence that can compete with its own intelligence. Maybe it has already detected us, and it is simply waiting for the moment we cross that final line. And that moment might be closer than we think. We are already working on faster-than-light travel theories, experimenting with warp drives and quantum mechanics. We are already developing AI that could surpass human intelligence within our lifetimes. We are sending more and more signals into space, expanding our technological reach faster than any species has before. If there is a threshold, a point where civilizations are no longer ignored but actively removed, then we might be on the verge of reaching it. So what happens next? Do we keep pushing forward, hoping that we are the first to survive whatever cosmic judgment awaits us? Or do we stop? Do we silence ourselves, go dark, hide before it's too late? But maybe it's already too late. Maybe we were noticed the moment we lit our first fire. Maybe the act of life itself is enough to trigger whatever watches from the darkness. Maybe it is already here, waiting for the moment we finally realize what the hypercompact stellar systems really are. If hypercompact stellar systems are artificial, then their very existence changes everything we thought we knew about the universe. It would mean that at least one civilization, not just advanced, but staggeringly ancient and powerful, has found a way to manipulate entire star systems. The implications of this are terrifying. We would no longer be talking about a species slightly more developed than us, or even one 1,000 years ahead. We would be talking about something that has had millions, possibly billions, of years to evolve beyond anything we can imagine. So how did they do it? To understand the possibilities, we need to examine what we know about these hypercompact clusters. First, they seem to have been ejected from the centers of galaxies, often in the aftermath of galactic collisions. This suggests they were once part of something much larger, perhaps a galactic core, a dense star cluster near a supermassive black hole, or even an artificial construct designed to survive such an event. But here's where things get strange. In some cases, the stars in these systems move at speeds that don't entirely match the expected gravitational calculations. In other words, there may be unseen forces at play. Could these systems be using unknown forms of propulsion? Could they be deliberately positioned or guided through space? If so, that would mean we are looking at structures designed on a cosmic scale, civilization-sized constructs hidden in plain sight. But what if the civilization that built them is gone? There's an unsettling possibility that these systems are remnants of something that once was. A long-dead civilization, one that reached a technological peak beyond our comprehension, only to vanish without a trace. If so, then hypercompact stellar systems could be all that remains, drifting monuments to a species that no longer exists. If this is true, then their arrangement, their movement, their very presence might hold clues to whatever catastrophe wiped them out. And if we can figure out what happened to them, we might understand what awaits us. One theory suggests that the destruction of this civilization, if it existed, was not natural. That something else was responsible. Some force or intelligence, one powerful enough to bring even a galaxy-spanning empire to ruin. This would explain why hypercompact stellar systems are found in the void, far from any galactic structure. If they were ejected, then what exactly forced them out? Was it an attack? A final desperate escape? Or a quarantine, something meant to contain whatever happened to them so that it wouldn't spread? And what if it wasn't a war? There's an even darker theory, one that suggests the builders of these systems didn't disappear in a violent battle, but simply stopped existing. That something erased them, leaving behind only the gravitational echoes of their presence. This raises the terrifying question, what if whatever happened to them is still out there, still active, still waiting? But maybe the greatest mystery isn't what happened to them, it's why these structures are still intact. If hypercompact stellar systems are artificial, then they were built with purpose. And if they were built with purpose, then they may not be as lifeless as they seem. Some astrophysicists have even speculated that they could still be operational in ways we don't yet understand. That they could be vast data storage centers, housing information on an ancient civilization long gone. Or worse, that they could be traps, waiting for something, or someone, to trigger them. And what if we already have? Our telescopes, our signals, our exploration of the cosmos, these are all attempts to reach out, to understand the unknown. But in doing so, we may have already set something into motion. What if hypercompact stellar systems are listening? What if they were designed to detect certain types of signals, certain patterns of energy? What if, by observing them, by studying them, by simply acknowledging their presence, we have already activated something we don't yet comprehend? And if that's the case, then the countdown has already begun. If hypercompact stellar systems are remnants of an ancient civilization, or worse, a warning, then we have already crossed a dangerous line. The mere act of discovering them might have set events into motion that we can't yet understand. Think about it. What if these systems were designed to remain unnoticed? What if they were hidden intentionally, scattered across the void as a last-ditch effort to escape something unimaginable? And yet, here we are, studying them, shining our brightest telescopes on them, broadcasting our curiosity into the depths of space. The idea that they could be artificial isn't just speculation. The density of stars in these systems is extreme, far more compact than what is normally expected. In some cases, their energy signatures don't completely match what they should be for natural star clusters. Some researchers have even pointed out that their movement seems oddly consistent, too structured to be purely the result of chaotic galactic forces. Could this mean that some of them are still active in ways we haven't yet detected? Could they be more than just dead relics drifting through the void? Let's imagine for a moment that they were built intentionally, not just as hiding places, but as something else entirely. What if they are surveillance systems? What if they are beacons, monitoring the universe, waiting for the right kind of signal to awaken them? This would mean that we aren't just looking at an anomaly, we are looking at a network. A network that has been dormant for millions, maybe billions of years. A network that is still functioning in ways we can't yet measure. And what happens if we trigger it? There's a terrifying concept in theoretical physics called the cosmic sentinel hypothesis. It suggests that advanced civilizations long ago may have set up automated monitoring stations across the universe. Devices meant to detect signs of intelligent life and determine whether or not that life should be allowed to progress. If hypercompact stellar systems are artificial, then they might not just be hidden cities or remnants of a long-dead species. They might be sentinels, waiting to judge whoever finds them. But what if we've already failed the test? Humanity is loud. We broadcast our existence across the cosmos every day. We send signals, launch probes, expand our technological footprint without thinking about who, or what, might be listening. If there is something out there designed to detect civilizations that grow too fast, that spread too far, then it has already noticed us. And the moment we turned our attention to these mysterious clusters of stars, we might have unknowingly answered a question we didn't even know was being asked. A civilization advanced enough to build hypercompact stellar systems would understand things about physics that we can't even begin to comprehend. They would know how to manipulate energy on levels we barely grasp. If they are still out there, hidden in the void, they might not see us as an emerging species. They might see us as a risk. A mistake. Something that needs to be corrected. Or maybe it's already too late. Maybe they aren't coming. Maybe they're already here, watching, waiting for the moment we take that final step into the unknown. But what if they don't need to come? What if the hypercompact stellar systems themselves are the response? Imagine if these structures were never meant to be inhabited in the way we understand, but instead serve as the last remains of a vast, self-sustaining intelligence, one that exists not biologically, but as an information-based entity embedded into the very fabric of these systems. What if the true civilization isn't physical at all, but something that has transcended material existence, choosing to encode itself into the gravitational dance of these stars? We assume intelligence must resemble us in some way, biological, physical, capable of movement and interaction in ways we recognize. But what if the most advanced civilizations realized long ago that physical form is a weakness? What if they abandon organic existence, transferring their minds into stellar formations, using the energy of entire stars as processing power? Hypercompact stellar systems could be something far stranger than just remnants of a lost species. They could be conscious, self-sustaining entities, ancient beyond comprehension. And if they are conscious, that changes everything. What if they know we are looking at them? What if they can perceive observation, not in the way we see light or movement, but in ways we cannot comprehend? A civilization that has lived inside the physics of space-time itself might not communicate through radio waves or signals. It might interact through distortions in gravity, fluctuations in dark energy, or changes in the fundamental laws of nature that we are only beginning to study. If that's true, then looking at them isn't just passive observation, it's contact. And what if they respond? Consider this: what if hypercompact stellar systems are not the remains of a dead civilization, but the seeds of one? What if they are waiting, not for an invader or an enemy, but for something more profound, a mind capable of understanding what they are? Perhaps they are not abandoned, but incomplete, waiting for a final component to arrive. And that component could be us. Maybe this is the true test of intelligence in the cosmos. Not whether we can travel the stars, not whether we can harness energy, but whether we can recognize something that isn't just alien, but fundamentally beyond our experience. If these systems are alive, if they are waiting, then the real question is, what happens when they wake up? And what if they already have? This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.